for me, for Algebra 1, if we just get through the content, the wording that we want to use, I'm fine with that, and we can worry about periods and colons and things like that later. For somebody like Rosa, so you can go in and make those changes that we need to make for formatting issues, or somebody can volunteer to do the formatting things. But the main thing is to get through those issues today, as well as the timing of the survey. When we want to get it out, when we're meeting, kind of backtrack from there. And then you need to talk about the survey and the questions itself. Can you tell us about how long do you think that would take for us in our discussion, so that we can kind of get a timeline of how long we have to work on our other things today? What's your ballpark?
We're just talking about how to do it. So
like more talking about changing some questions and things of that nature.
Yeah, I love to change it. I gave some options, and I love to choose.
Choose one, yeah.
Choose one of those options. Okay.
That should take her.
I would think so.
Okay, and so we can have some discussion from you. When would we want to do that? Do we want to do that at the beginning or at the end of the day? We just need to make sure it gets done.
Yeah. Do we know where we're putting it?
I have, as far as storing the locations, like the links, that's another thing I need to know. Does it store? Does it download to Google? So we'll download for
It's in Google, and anybody that has Google, I can share it.
Okay, so we can do that. So the links, and what I've done as far as links go, I've reached out to the Missouri Council of Teachers of Math. The president and vice president said they thought so, but I haven't gotten a confirmation back from them yet that they would have some links. But I talked with Kansas City area teachers of mathematics. They're more than willing to put the links on their website.
I was just wondering where we got a place in the bees.
I'm trying to put the links on math associations around the state so that we can drive teachers to go to their local math organizations. Get feedback, because I think they would like to try things, and I've gotten a confirmation from Kansas City area teachers of math that they would be glad to have the links. And again, it's just the links. But I haven't gotten confirmation from NCTM. There was a discussion, but then I didn't get a confirmation, which I can email as soon as I get back and find out. For sure, we can just put links on their webpage for people to go through. And then Desi is willing to send out an email to everybody to direct them on where to go to get the information. So, we can get that done, but we'll have to, as a team or maybe a group of us, we don't have to do that today. We would volunteer to put together what we want to have for them to send out. And I don't know when in case the ATM, I'll have to contact them, like how far in advance will they need to know what the links are to get them up on their page and give them a timer. So those little things, those are all, they seem like little details, but yet things that we have to, those are the devil's in the details of getting those things worked out so we get the feedback. So that's pretty much, we've got a confirmation from Kansas area teachers of mathematics that they will house the links. I'm hoping NCTM, and I think they probably will, just house the links so that teachers can go to that website. I don't want to send out 7 links in an email for people to find that they might lose if we can put it there, but if you say, go to Kansas City area teachers of mathematics website, here's this one website, the links are here, would be easiest for the teachers. Nancy?
I was just going to say, could we approve the minutes of yesterday, set the agenda, so that when I'm making those notes, it looks kind of,
Okay.
Because right now we're discussing some stuff, and I'm not sure how to put that in.
Okay, so we're just we want to look at the minutes from just yesterday.
Well, I think it'd be nice if we just got those out of the way and then set the agenda.
Okay, so these are the ones that you just put in Dropbox?
I put them in yesterday, and I took some highlighting out and put them in a few days ago.
All right, so let's look at these. So those of you that don't have a laptop, would you look at it? Are these up here?
It's in the minutes folder, and it just says, I think, May 27, or May 26, Nancy. Because I wanted to make sure that, since most of the minutes were hands, that it was distinguished.
Just from 5 minutes ago.
Darrow's name spelled D-A-R-O.
Yeah, no.
I think it's
D-A-R-O.
That's me.
I'm just sick of stuff. I don't know why. I mean, what I mean by that is I see something and I remember it. Well, yeah. Coleman is in the, because Coleman is the APLA. I'm focused on that. Alan and Dara were along with it.
Are there any discussion about minutes?
Is that okay at the bottom of that list was, I think, like 300
Yeah. I think they
I don't have a minutes phone problem.
You don't have what?
A minutes phone.
I think is it 6 through 12 years? It doesn't say 6 through
12 minutes, and Gassel/Nancy/Julie.
That's not, not here.
I think I might remember so maybe that's
Okay, maybe it's the same folder we've been putting minutes in.
I don't have that.
I've seen it, but-
I've seen it before.
Yeah, I have to.
What's the deal with you?
It's not like-
Okay, so it's supposed to be in the folder?
Yeah, the folder is 6-12.
It's about a third of the way down.
Well, it all depends on if you have a Windows or Mac, is where it's located. The name of the folder is 6-12.
I've got the name of the folder, but I do not have
I don't either, so.
minutes.
Some people can't see the folder.
Oh, there it is. It just starts with Mass 12 instead of May 26.
Yeah, I know, it's 2 minutes too.
Man, it's going to, it was on its feet this morning instead of mine.
It's
not-
tired. This is
I would say
tired.
it's not going to be next week.
I make a motion to approve the minutes.
With a change in bottom.
And correction.
We have special filter, right, with the correction filter. Any, all those are second, okay, any, all those approved? All opposed? Any abstentions? No, so I guess it approved on winter. Okay, so today's agenda, we have these items to finish. We have to finish off eighth grade. We have to do algebra 1 and algebra 2. And we were asked to go back and look at the comments on the DESE website about from the surveys. And then review comments about geometry and the survey. So those things are the priorities, I would say, to get done today. You know, the math practices, all of those things are really important. Whatever time we have left at the end of the day, we'll get as much done as we can. So I think we have to get the eighth grade done, the algebra 1, the algebra 2, and then we can look forward to then looking at the comments. So does anybody have any preference for the order? I think we definitely need to start with finishing off eighth grade, since we're the most familiar with that.
We have to do what?
We definitely need to start with finishing eighth grade.
Yes.
Yeah. So we need to start with there, and then begin to work on, then we're going to go right into algebra 1, and then algebra 2. Okay. And then the time we have left after that, we'll look at the survey. And the comments concerning geometry, if we can does the geometry team feel comfortable enough with what you've done the survey out.
Yeah.
If we don't have the time to review comments, because those are things.
Yeah,
that
yeah,
we'll
that's
say.
right.
So
People
you
came
probably.
down and made comments over the top.
Okay. Okay, all right, yes, sir. It was perfect now, it was a perfect job. Okay, so, Tiffany, do you want to just pull up here and plug in and finish off eighth grade? So let's get out the, folks, we pull out the eighth grade materials. And do I have all the forms yet for people filling out for their, does anybody else? I'll come right in.
I'll go.
You'll, what mail you're saying, did you say? You can, you have, I mean, I'm going to take them over later today, so we don't do it right now.
I put the hotel receipts.
But I don't know all that necessary today.
You got one?
Well, you just get a set them out for lunch. And you just set them out. You don't get a, you don't get a specific amount, you just get a set them out. So, no, they don't take receipts, so don't worry about that. So it's $9 for lunch and you said, I think they pay, they will pay dinner if you get home after 7, but I don't think they pay, we give you dinner anytime
That may not be that hard to go home. Yeah, I don't want to do it, but.
There we go. Okay.
Can you give me that now?
Yes. Did we finish geometry?
Yeah, we did.
P and functions, I think.
Yeah, we did not do functions.
And the reason C is in red is because that's the one where we ended up throwing it in
Yes.
there just in case, right? Yes.
We did this economics.
I have a question, just, letter A is titled Work of Radicals and Integer Exponents, and then AEIA2 is also titled that. And I wondered if we wanted the exact same, or if we wanted something, I'm not sure what to call it, but like working with groups, or, do you know what I'm saying?
Yes, and I think we want something different. Okay.
Yeah, I have a note that that was a little non-specific, which is fine for a heading, but not.
And I'm not sure what to put there, but, not all equations, not all expressions. And we're just talking basically about groups. I don't know where to put.
I think when we deal with that, we just need to be consistent. Whether we talk about it right now, 1 grade, whatever we want.
Say, what intervals?
Investigate concepts of square and cube roots.
Is that all you're doing, square?
Yeah.
Okay, yeah.
You can take a word again.
Again?
Is everyone okay with the explain why numbers are and are not perfect squares using area models? That was a suggestion we got from the DESI. So you can unread it.
Where are we at? What's in red right now? The, C. The example we pulled from the business area. So I'm reading.
Yes. It's not new, but I wondered why 3 and 4 were not part of the same thing. Yeah, but it's, you know, just calling it like scientific notation or working with scientific notation and then.
Okay, so you want,
Don't necessarily change it, if I'm just throwing it out there as, when I read through it.
What does that phrase that last after the column of three?
Yes, just say the same thing.
Like, for example, with our 3 times 10 to the 8 or something, 7 times 10 to the 9, so
Oh, I think it's-
20 times 3.
Yeah, words in this, I think.
Millimeters per year.
I think something like that.
No, that really is what it says. I have an example, but I checked, that really is what it says.
That is what it says.
Really what you're doing is comparing
Yes,
quantity.
yes.
And so,
So like if one is 2 times greater than the other one. How many times larger? Well, I think there's really 2 parts. One is, can they express numbers in scientific
Right.
notation? The second one is, can they compare 2 numbers expressed in scientific notation by telling how many times one is larger than the other? And I think it all ties in with the agency and the next one.
Could you make that a second sentence and say,
or could you express how many times? Or could you get rid of to express and just put determine?
And maybe using, approximate on that, because I think the focus is, the exponent on the 10 is what's the most meaningful. So then you're approximating, so maybe you put the word approximate in there somewhere.
I just hate to combine them because then it changes the numbering and if we're still looking to use some resources that are connected.
and can we say something that's like how many times? Do we say the ratio or the ratio?
Right, ratio or what is the scale, and multiple the other, or what's the scale of that, that's
And I like what Julie said, I think we're actually
Right.
estimating, we're not calculating.
I agree with that. I'm just waiting for this notes, right?
Right.
And determine approximately how much larger one is than the other.
Well, but I think there's specifically one ratio, right?
Okay.
I
It's
don't
not
know.
just-
I don't think it's one ratio.
No.
I think it's possible to look at the whole number, maybe it's 9 times 10 to the 15th,
Right.
and 3 times 10 to the 12th, and say, well, that's 3 times 10 to the 30th.
That's what, yeah.
Right, right.
That's what I think.
But it's not difference, it's ratio. We're not wanting to subtract.
We're not going to perform an operation other than division.
Right, right.
Approximate. And just determine how many times one is than the other. Larger.
Okay, we can look at
But if you're just going to calculate a straight ratio, then that's what you're doing in part 4. Perform operations, and it just looks to me like 3 is intended to estimate.
Yeah,
So
right.
I don't disagree with what Nancy Bergfeld said, but for example, you wouldn't have, 2.3 times 10 to the 5th versus 7.1 or something that you wouldn't, that wouldn't be obviously a whole number.
I think you're absolutely right, it's all in front.
Yes, yes.
it. So is that better?
I think so. Sounds good.
And when I look through scientific notation, is there anywhere where they're asking to convert or standard deviation?
I can't hear you, Kathy.
Is there any place where they're asked to convert between standard form and scientific notation?
Well, I personally think that that's what they wanted to do in 3,
That's what I was asking.
Yeah.
That's what they're-
is to, and that's why I said, to me, 3 and 4 are both about scientific notation.
I agree.
Yeah.
But when I read that, I guess that's your take on it, but when I read it, I don't see that.
Well,
And I agree.
and I have that note with respect to 4A. Perform operations where one is expressed in scientific notation and the other is in decimal. And yeah, or that's included in that standard. So
Yeah.
I take that to mean that you know, a conversion is embedded in that, but we don't say
There's usually, you know, decimal and scientific notation, usually you have your first number where you have in decimal notation. It's 1.35 times 10 to the 23rd.
I know.
Okay, so I think that's basically like that decimal.
No, I think they need some that are just a number. And you have to convert it before you can do the operation.
So like .003 plus 3.7 times 10 to the 23rd. I
So
thought that.
essentially you convert both to one form and then.
Yes.
Right, because that's what I was saying, so I think that
That's
conversion
right.
is an end.
My first thought on that would not have been that.
See, and that was my note, that I think that's what they mean, but I don't know that
It's not
so
explicit,
clear.
yeah. If it's clear enough that teachers will recognize that.
Do
So,
so.
you need clarify or what?
I'm not having any problem with it. When you they know that they have a number that needs to go to scientific notation, and it's a big number, a small number.
It will automatically switch it from scientific to standard and will
Right.
add or subtract or anything, they will.
Yeah, I think that's what 3 means.
I don't think there's, I mean, okay, we're supposed to go to scientific notation, and we go, I'm not,
So,
a lot of them do it in science and stuff.
You could say where problems include numbers, both as decimal and as scientific notation.
Just the standard.
That would be extremely clear.
I think we can wait till the survey comes in.
do I need to combine 3 and 4? And we're not
Rather not.
I think we can leave those alone.
Yeah, I think the focus of 3 is the estimation, and the focus of 4 is the, that's very content.
But as Kathy was saying, I hope that the focus of 3 is both writing them and estimating them.
Yeah.
So, do we say generate answers or write answers?
I think you could say something like, express very large and very small quantities in scientific notation.
Yes,
That would be good.
that would be good.
Is that not what you
And I just imply the number.
Yeah, right.
Although, you know, in science, we express all sorts of numbers in scientific notation. They don't have to be very large or very small, conceding that large and small is
Well-
in the eyes of the beholder. However, if you can do it with very large and very small, you can do it with normal size, whatever that means, so it's not everything, but.
So, just
Yeah.
Very small.
Yeah, I say and.
Yeah. Yeah. Oh, that's right.
where,
Very large and.
Yeah.
Okay, and then on the second one, on A, consider where numbers are both decimal and scientific notation are used. So that they understand that there are two different numbers,
The scientific notation is two different.
where numbers.
It says both decimal and scientific.
yeah,
But to clarify, you could say something like standard decimal form and scientific notation form. I'm not trying to make it two words,
Yeah.
but to avoid, you know, that
Right.
confusion, maybe that would be a way to do it.
I think just the issue of wording, are we going to call it standard decimal, or going to call it standard notation? I've seen it written as ordinary notation, I mean, there's different wording.
I think
It's not standard form, but
a number in
it would be
scientific
scientific
notation
form.
by a number in scientific notation.
it could be, but I also think that you've got the operations where you have a decimal and you have scientific notation and they have to go.
Most of the books, I mean, that I've seen,
I think it's
just call it decimal.
Right. Yeah, it's got decimal, not standard.
That's,
Decimal form. Didn't we say decimal form?
Yeah, decimal form and scientific notation form.
I don't know if that's, you need scientific notation, you don't need form.
Scientific.
I think they were fine.
Is C talking about engineering notation, is that what they're referring to? Is C talking about engineering notation like the Terra, Vega, Omega?
no, I need some calculator.
Okay.
What does this
Yeah.
mean?
Because it looks a little different on
Yeah, and I see kids come to me, and how they put scientific notation in their calculators is they go 1.34 times,
Yeah.
symbol 10, caret, blah, 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 and, you know, and that's okay, but if you use the EE key, then you don't need as many parentheses, and so I thought that's what that was trying to say,
Yeah.
is to actually use the built-in functions, which I think is a good idea, so. you know,
And also for them to recognize on their calculator what scientific notation, because it looks different on different calculators.
Yes.
So is the purpose of that standard to be able to read the calculator, to be able to use the calculator that you
Oh.
don't
Well, I think it's both, yeah.
Because to me, that's just saying read the calculator.
So, yeah, I'm using the terms, calculated for scientific notation.
Since it's already been generated by the technology,
Yeah.
so I'm not talking about how you get it in there.
Well, and that was one of my notes. I wanted to expand that to make sure that what we're saying is that they need to, well, and this is just what I would like, but I would like for them to have at least been taught what, because I don't think it's really obvious, the EE key. I don't think that's really obvious to kids, or that you would experiment with it or figure it out on your own. So, but if they actually see it, it really is very handy down the road.
So you just have hand use after interpret.
And I say as a parent, I really appreciate that, because a lot of times schools will throw technology at the kids and not teach them how to use it.
Right.
Just expect them to sort of pick it up and find it on their own.
Which I, you know, I teach myself stuff all the time. It's really a hard
And
time.
that's the technology that they're use.
To interpret and use technology to, for
No,
scientific.
we're not going to interpret technology.
Yeah.
I don't know what this sentence doesn't.
And doesn't current use scientific notation has been generated by technology?
Definitely.
Yeah, going back up to A. Oh wait, we lost it. Yeah, A. I think it's just decimal and scientific notation. I don't think you need form.
That's what we have.
Being an English teacher, because it's decimal notation and scientific notation. If you want to be parallel, and then you would notation, then you would teach notation twice.
Okay, decimal and scientific notation.
I think that's what it was before. And
Yes.
Because that was the problem.
I don't think teachers are having that problem.
No, I don't
They have a question on the surveys, or they'll think. I'm just saying, I mean, it's just English, it's just English, it's not a math problem, it's just English.
I agree.
Yeah, I don't think we need more either.
That's not.
I would like to see to mean both,
And it doesn't,
and it doesn't say
I
that.
mean, both what?
That you put it into a calculator or you read it from a calculator.
Oh,
It's
okay.
talking about being generated by.
What you said.
and interpret.
We need to
Yeah.
discuss.
Scientific notation using technology. How about that?
Whoever-
How about,
I would accept the built-in scientific notation function on the calculator. I didn't hear everything that was said down there, but I would have considered it something like the built-in scientific notation function instead of, you know, people just going times 10 or whatever.
Take your capital I out.
are we happy?
Yes. Happy.
And put in interpret scientific. Just one green line, that's all.
Yeah. Draws your attention.
Well, you know, we went into science, but then to input and not just interpret. Are you good?
Where did the example come from? Use millimeters per year for C4 spreading?
I think I made that up.
Because I can think of a lot of other things that would not be on a controversial subject.
I don't understand why that's not personal.
I don't either.
We're not getting them to help us.
The C4,
We're not
spreading a controversial topic.
Oh, well, essentially C4 spreading assumes certain models for global warming, which have been not shown to be true. Sometimes it rises, sometimes it falls. You can't, essentially, I'm concerned about it being a topic that could be potentially controversial.
But if it's not spreading, you still measure that millimeter.
Right.
I
Regardless
mean,
of
you
whether
can
it's
measure it
not.
and prove it is or it isn't.
Or C4 change them rather than spreading.
C4 no, well,
Yes.
spreading.
No. No. No, spreading is an increase. Spreading is an increase, it's not a decrease. If you want to have a neutral term, say please C4 change.
On a different, same phrase there, but a different question, you know, use millimeters. That doesn't suggest that it's in scientific notation.
Can we, and can we like look at that or maybe add another example in because we're getting tied up on an example? So to move forward, because we've got a lot of work to do.
We'll put it in Tiff's hands.
Yeah.
Right there, modification example.
Subduction is the opposite of seafloor spreading, subduction. Seafloor subduction.
Well, we're not going to say
We have a tremendous amount of time, things we have to be done.
That was a learning moment.
They're going to be online, you have to take advantage, let's move on, please.
I made a note for it.
And yeah, and we make a note, and if people give feedback on that, then we can go back and change. Okay, so what are we ready for on?
I'm good with 5, anyone have a problem with 5? A 6, I just want to point out that one of the things we excluded in this was the use of similar triangles to the slopes. That's something we talked about earlier as a alter. Yeah.
I'm not moving on, I mean, I'm not trying to move on, but I just have an idea. We had the 8th grade science or social studies, and we could look at some of those for examples to make some cross-curricular examples.
Well, and that would be a really good point, that we could add an example in if we can find some things from 8th grade science, or it wouldn't have to be 8th grade science, from science, wherever they use scientific notation, that we could pull in, but yeah, it would be nice if it was 8th grade. So great suggestion, we can go back to.
I think it's interesting, put it back in, or you're submitting the detail.
I just wanted to note that to the group that that was one of the few standards that we said we were getting out way out
Yeah.
over whatever.
Yeah, we said
That's
that was
discussion,
Okay, so we do a 6, maybe on 8.
Yes, I want to make sure that on 7, or I don't know if it should be the whole thing, no, 7, that we put solve linear equations and inequalities in one variable.
And hey, we're really wanting the students to give the examples, right? Like if we tell them we want a linear equation with one solution, they can just make up 2 that will fit that, or that's what we're wanting on it.
I think so.
Okay, I just want to make sure that we're really wanting the students to do that, how much time they can. Okay.
Anyone else on 7? 8,
As usual, I don't like to understand, if you can find a better word, I'd be happy. But maybe there is a better word.
Are you saying B?
B and C. I can live with it, but if you can find a better word.
Do you have a suggestion? How about determine for B?
How is C any different than A, except?
Right. That was my.
We could
Well,
systems instead of.
This is systems and 2 variables, and 7 is
2
1
lines, 1
variable.
rest, I don't have a solution between the 2.
I kind of like explain, I think that's.
Which one?
On B.
B.
Explain why solutions to system of linear equations.
Corresponding points of intersection in the graphs.
They would definitely have to understand
would justify it.
Maybe he keeps it the same deal,
And I think we're going to move the river. That would be, okay,
So will that work? Okay.
then okay, we're
Good
good
on
on
eight?
Are we down to F?
Yeah, it's just one.
Awesome.
Can I, because I don't see it when you say graph systems of linear equations.
Can we go back to
Well, but is it, are we just going to graph them, or are we going to use them correctly to solve?
Well, don't you think that's what B and C, where we talk about factoring that on,
Yeah, I think
Is that one?
we can analyze it.
I think
yeah, B, the real world has that.
Yeah, because E also says also algebraically also.
But it doesn't, it says algebraic, it doesn't say graph.
But it says work for inspection.
Yeah.
So inspection two, that's.
do that and be graphic.
Just want to make sure.
And I would change C to graph functions from tables instead of figure.
And for functions, or?
Yeah, C. Make it plural, graph functions from tables.
That's about that.
Current functions.
Oh.
Yeah, instead of singular. Are you okay with that?
Well, I think you still need the
I'll
balance.
tell you, see,
Yeah.
and what was the purpose of that one?
You should have more than one function.
Do we want that at eighth grade? Do we have them do?
I don't think they're necessarily
Yes.
graphing multiple ones at the same.
Not the same thing, but instead of graph a function from a table, know that if you're in a square field, it doesn't need to.
Just how much money do I for?
Well, we have singular in the other.
Yeah.
That's true.
I think that A, the purpose of A was for them to just explore a function, what it is, how to graph it, et cetera. And then when you get down to the lower ones, it'll talk about comparing functions and multiple representations.
Back to this. Yes, back to this.
Under A, I would prefer recognize rather than understand.
I'll have to think about that one.
But that really.
I think that really lowers the,
Yeah.
and
I think they're.
Less about.
that's more than I just identify instead of.
It narrows the scope of the sentence, or what the standard of qualification is supposed to be.
Is there a better word?
That's a very big idea right there, that we want to really have a deep understanding of.
Okay.
We want you to bold that.
Goes to the core of what a function is, which is a key thing in all math.
And I think point B then actually
Gives me
is an assessment of their understanding of that. So I think B tells us what we want to see.
It's part of that understanding.
Yeah. I think the understanding A would look like the answer to B.
That would help.
Does that make sense?
How to be assessed.
If you have absolute numbers of all that, can you have two different ones, a function that will give you more than one output?
Not if it's a function.
If it's a function.
For each input, there can only be one.
That's the definition.
It's not a function.
Okay.
Okay, so two,
we want to compare the properties. We compare the properties of two functions, each represented in a different way, because to me, compare multiple representations represented in different ways is redundant. But I don't.
Yeah, no, I agree with you. What you're comparing, I'm not wedded to the word properties, but you're not comparing the representations exactly. You're comparing the functions.
Characteristics.
Yeah. Of two functions made using different representations. I mean, I think that might be a little awkward, but I think I agree with you. I don't fix it, but then I think it's okay to list the four choices.
Yeah, I like that.
Yeah.
So this is the only place I've seen this in all of these. Why is it here important to be able to do it by verbal descriptions?
By what?
By verbal descriptions?
This is where the student is first realizing from a contextual situation what a graph would look like. And so many times they'll read a description of Anne drove 40 miles in the first hour, and then she did this, and then she did this. Show me what that graph would look like, so that they're connecting the verbal description with actually that graph.
That's the fluidity we want to be able to do. Equation, graph, table, and context of verbal description.
And you can bring in things like, if it constant change, it varies,
But is your question that we're using verbal description instead of in context because all along the way they
Yeah.
Well, sometimes it's in context, sometimes it's not.
Right.
You could have verbal description that's not in context.
And so that's what we need the clarification. The context is within the context of our real world problem, but a verbal description could be the graph of
Yeah. Increases at a certain rate or something
Right.
like that. It's not necessarily contextual.
It wasn't some of the standards that we reviewed. I mean, this isn't the first time I've seen it, so 6, 7, 8, but I do realize it's the first time it appears to me.
so are we okay now with the way it is? Like,
And I'm going to assume when we look at, I guess when we're back down reading it, that we can do different representations.
I can't hear you.
I'm just going to assume that we're looking at, from what I see here, it's mostly graphs, graphic functions are going to be in tables of values, or is it going to be main and looking at graphs?
What number you want to have?
3. And I'm fine with just looking at graphs.
Anything is visual.
And that's fine. It just gets in the connection line, that's fine.
Good.
When it says give examples of nonlinear functions, what, do you want to give some examples there? And e.g.,
I don't think it's needed there.
oh, okay.
But I guess, I don't know if this is the question, but in what form would you like your examples? And maybe you're saying any would work, but I mean, do you need them to be able to describe verbally a situation that would not be linear? Do you want them to say, well, square the x and then it's not linear? Do you want them to say, well, the second differences or the odds and it's not, or?
And
I mean, to me, that, it's just a good run of the line.
And I think
Too far.
part of that, when we were talking about functions, which was one of the questions that I asked, is that A and B were just strictly pretty much focused on graphing. So if you want them just to give an example of a graph of a nonlinear function, or a
They give a
Right.
equation.
because you probably, and I don't know if you, because that's why I asked about A and B and C, is that the examples are, A and B are really focused on graphs, but you really have to talk about equations that correspond with graph, which I understand in 8th grade why you wouldn't do. So if you want graphs, I don't think it matters to do, I guess it's best to leave it open-ended and let the teachers decide, because I think that that would be fine to leave as it is.
How do you turn it over to the test writers to give them a table of values and expect them to determine which one is linear?
And that's actually one of the points of this, is so that they will know it's not linear because they're not in a straight line. So that is one example we could give, but you could also give an example of the perimeter of a square as it grows, as the side grows, is linear, but the area is not. Because, but the bottom line is because they're not in a straight line, is the main point for 8th graders to pick up here about connecting that graphing with the context.
So maybe to make it like B, recognize that graphical nonlinear function has a non-constant rate of change.
But that's not the only kind of part of that. That's why it's nice that it's open. I don't think that we can list. And I know what you're saying, Julie, about
The testing.
yeah.
And I totally agree.
Absolutely.
I don't know how you fix it. I mean, there's graphical or other examples that where it's okay to confine itself to graphs, but
It needs to be open for that. I hear you.
yeah.
Me too,
Just putting one little question marks right now.
And then you guys can.
Put green in examples or whatever, and then we'll move on.
And then you guys can look it out, put it out for survey and see what you guys can.
We're down to 4. Could we put use functions to model linear relationships between quantities?
Both of them heading as well as
Probably also.
You want to hear also?
I didn't put it in the heading simply because when it gets down to 5, sometimes that's, well, I guess it is linear, but it's piecewise linear at times.
Sure.
Yeah.
I don't think it needs to be in that.
And it has linear numbers.
Right, so that's why I put it just in
my
the
question marks there too. I was asking as a question, I was.
Well, it could be continuous, but still be piecewise. And,
Right.
Yeah.
okay, so in 4 also, in B, where are we here? I wrote, determine the slope and the y-intercept of the linear function given a description of the relationship or from 2 points. Because that's
It's supposed to be on the table.
right, it's back to that verbal stuff that you were asking about before, and that's still part of that that connecting all of those representations.
Do you not want them to determine the slope and the y-intercept from the graph? You want that in there too?
Yeah, the graphs.
Did that
Yeah, I
line
love
change?
the graphs.
So how is B4 different than the cluster? It looks like the same wording to me. Linear, not, so we don't want later questions. None of this 5 wouldn't have. Okay.
And then on 5 is 4
So
again.
here, B,
We need to take out
With-
tables.
take out tables, or things that were in here.
No, I didn't.
Okay, I actually like the inclusion of tables.
I should.
Okay, so,
Okay.
but you do have on your code for 5, it looks like you've left out your B.
Oh, thank you. I did that last night. The question here was, we were discussing whether or not to include discrete continuous.
In the examples.
I personally don't mind including it, but I don't know if you have to use the word discrete.
Because it'll have to go in the glossary.
Well, yes, I mean, I think it should just, personally, it doesn't need to be there, you could have continuous, discontinuous, so we would have that. Because that they would get, anybody would get
I
that.
think it's nice to put that in there because I think it's something that when we look at contextual sequential problems, a lot of times we skip that, and we should.
No, it's a great issue.
So
Yeah.
we just like, then,
You say not non-continuous or discontinuous. Discontinuous,
I have something else I want to bring up in 5. I really thought that 5 was about describing the relationship from a graph.
yeah.
That says describe the graph.
It's a sketching graph.
So, no,
Oh, you're talking.
describe the functional relationship. I wrote describe the functional relationship between two quantities from a graph. I want them to look at the graph and describe the relationship. Does that make sense?
Well, it's got to be able to sketch a graph, so I don't think you need from a graph. I think it's describe the graph and the function. Describe the functional relationship between two quantities.
I know, but what she's saying is that it's going both ways.
I'm sorry what you said, Bob.
Yeah.
Describe the functional relationship between two
Quantities
quantities.
using attributes, and then that's,
And then the
and be able to sketch the graph and give a verbal. It's all one sentence, isn't it? There's no period.
But can't you give the relationship from the graph or graph the relationship? I mean,
I think that's what.
you think this is going both ways now?
Well, are we saying describe the functional relationship using those choices? Is it a constant, is it increasing, is it decreasing? So we're giving them, so those are the things we want to describe. But then the first part is basing, given the graph, and then the second part going the other way. Is that the way you're interpreting it?
That's not the
What
way.
I'm trying to say, what I'm saying is describe the functional relationship between two quantities from a graph, not just using attributes.
Yes.
Yes.
And then the parenthetical part, and be able to sketch a graph from a verb description. That, I think, makes it very.
And that's the back and forth,
Yeah.
that's perfect.
I had read it that way to start with, but I like the change of
Yes.
the phrase, the movement.
Tiffany, the weight falling off the shoulder.
Okay, back on the example, if you want to have.
I just made the room because we were done.
It's just a second, all it is just a movement of tectonic plates.
Hey, how about if you write it out and submit it to her, because that's going to be a Tiffany we decided.
Okay.
Because when you move it to, I'll one of it's 9 o'clock, this, and we got a load to do, don't we?
Okay.
You guys want to see if I can climb over a chair like this here?
The chair, it's trying to be more room.
I feel like I should have music playing as we're kind of,
Celebrate.
Oh, the lights are on. Oh, it's on.
Nancy, I'm going to send this to you, and I'm also going to send the sixth grade one, because she found it.
Yeah. You found yours? Oh, good. Or retired.
Love to make mine.
I think so.
Yeah, I'm not in the walk this morning. I'm sure he's behind the hand.
It's worth it not to walk that.
So I don't want to do all the work myself. I'll do that. I can share it, or you can share it.
Left in my purse.
Right now, share it too.
I'm actually liking it.
So you're usually never done that last time.
Yeah. Well,
It's decent.
How's the
What
English?
else?
Christina?
Yeah,
I still think if I share that, I then you can make one.
yeah, and that's perfect.
she might be, but I'm I didn't have any trouble, but I know she said she could get on, so.
Only one or two, we don't necessarily
That's nice, just like there's not really any parking lots. So I used to say that's supposed to be, I was going through hot wire, I really thought that's where it was supposed to, does that? Came back and I wasn't.
Oh, yeah.
No, I mean, short version.
Now.
Well, probably need this hand on this, making sure that one gets surveyed.
Are you familiar enough with the law?
I've only paid 3, this is my third time.
Okay, shall we go ahead and get started with Algebra 1? And there's some tweaks and changes that have been made, but nothing major, since it was put in the Dropbox folder. And I'm projecting those, a few tweaks and changes that were made since it was put in the Dropbox folder. I emailed it to everybody last night, but you may or may not have checked your email. It's also in the Dropbox.
This is the one from last time.
Yes, it is. Yes, it is. I did do it. And again, it's really, there's a lot of work, and there's a lot of work that needs to be done on it, especially after some of our discussions yesterday. And I worked until I had to work on another project last night, so I got to a certain point and didn't stop. But a couple of things, so I got started. I had to, for some reason, I don't know why, it wouldn't let me put in footers and headers in the format that I had, so I had to copy and paste it into another document. So it's working now. So anyhow, starting with the first one, number and quantity, extend and use properties of rational exponents. Decided, because Tiffany brought up the suggestions we were going through this, that really needed an example here, but also I think sometimes if we need an example, we might look at, does the wording need to be changed, tweaked, or adjusted, so that it's a little clearer. So, looking at number 1.
Was it purposeful, the coding change on that, Kathy?
Purposeful, but I mean, the coding change, we didn't make a decision as a team.
No, what I'm talking about is in the Missouri Learning Standards, that is the real number system rather than numbers and quantity. So it's RN rather than MQ. And so was that purposeful to make it?
Because we did not at the high school come up with a definite plan that we were going to use the same coding and domains. I put it here, but that can be easily changed. I think that's what we decided on as a team, and I'm fine with whatever the coding is.
I think if you're gonna stick with the same general idea, you guys are coding the same.
That's fine with me.
Would make it easier on the world.
I agree. So, other than the coding, okay, so that would be RN. Other than the coding, and we have to change, that's what we talked about yesterday. Number one, we have the conceptual category, and then you have the domain inside the conceptual category. That's what we talked about, because the first one is from the real number system, and the second one is units, so that's quantities, and that adjusts. Which we can go back and change, and that's up to the group as to what that coding
Is
is.
the same thing with functions?
Absolutely, absolutely. I'm fine. Coding is not the issue to me right now. I think we want to keep things as close and consistent as we possibly can for teachers when they're searching for resources to have some great resources to use.
And I only like the standard itself.
Yeah.
Okay, leave it as is.
Good example.
Okay, what about the?
I think the example is very helpful.
So putting the example in, then
Yes, I just want to make certain you understood that. I leave it as is with the example.
Yeah, oh yeah. And I put it in blue, I put it in blue and red, usually things that after our team talked about that we didn't decide upon, just basically that. So that's why some things are in blue and red that are not black. So we're you're okay with that being as it is? Yay. One down.
Take your pictures wherever you can.
And on number 2, I understand with the part where you have in red limit 2, and I know when we talked about it, we also just said rational exponents with a numerator of 1. And that is a very explicit way to do it, which I think is kind of the purpose of that limit 2 example, but that would be another way to make it very clear that we're not intending x to the 2/3 or whatever.
Because I think if you say limit 2, it means think that it's only that one function.
Right, and that's why I put it in variables limited to the nth of x as x with 1 over n. Because there had been some discussion on our team about square roots and cube roots, but I think you do square roots and cube roots, but then extend the idea beyond that, and then algebra 2 would take it to all fractional exponents.
So I think for additional words, plus this, would clarify what limit 2 means.
So, are there any changes that we need to make to this?
Exploring the one, did you not say?
Well, if we're actually writing out rational exponents with a numerator of 1.
So you want to say and rewrite expressions involving simple radicals and rational exponents with a numerator of 1?
I mean, that's my suggestion.
Or you can look at it, limit 2, right? You put it after limit 2 and then say, i.e., here's the example.
So why would you include that in parentheses?
Yes.
I see what some of I think that limit 2 rather than the fractional exponent means that you're not going from the fractional exponent to the radical, but you're limiting it to that.
Well, but when you have equality, it doesn't go both ways. So I think what you sign means both ways.
But don't we ask students to rewrite it both ways? Don't we give them a radical and ask them to write the fractional exponent, give them a fractional exponent, ask them to write it?
Sure, but I guess when I see inequality, then it means it goes both ways, doesn't it? So if I have x to the 1 over n, that means the n through the x. If I have the n through the x, that means x to the 1 over n. So when I'm setting the equal, I guess we can put down, translate both ways.
I would assume by looking at this that they need to be.
Then you can equal it both ways. What about Julie's suggestion about with a numerator of 1?
I think that as modified by.
Bob? Okay, Bob, would you say that?
Oh, I just said you could put it in limit 2.
Right.
Limit 2, exponents with a numerator of 1.
Okay, limit to.
Rational exponents.
And then put that as an example, as a blue G.
Limit to rational exponents.
And something.
Rational exponents with a numerator of 1.
But,
What?
but you have to say that n is an integer.
Well, if it's a rational exponent, you can ask it.
Limit to.
Right. Rational exponent.
Numerator of 1. Limit rational exponents to numerator of 1.
Well,
Because in algebra 2, we said we're doing fractional exponents or numerators other than 1, so that ties the 2 together.
Okay.
Rational exponents with a numerator of 1, and that makes it.
I take Nancy's point. However, maybe it's this one where you take it on faith. I know that's not what we. Ending up being correct. So, I'm for sure it's going to be 1 or something.
And put a comma in
And I
there.
know that, but.
I think change there is also.
And I'll put that. And are we fine with this? And this was originally at A, B, and C, but Stephanie brought up, or not Stephanie, Tiffany brought up that B was actually done in 6th grade, converting units between the system.
However, we had the discussion yesterday that we wanted them to give a few more conversions, like squares and cubes and different things, so I see this as some of the ones that they do before. I really like the A, B, and C, but I like the, some of the examples
So identify and label using appropriate to measure within the context. And
That's
then,
very helpful to me when I didn't also. That's good.
so leave that there, so.
And then maybe your IE there that includes,
On A.
well, I mean, it just doesn't seem to be problems involving rates, time, linear area, and capacity. Something doesn't seem parallel.
Suggestions?
Problems involving linear.
Then that takes out the area capacity.
I think she's going
No,
So
what
then-
does that mean?
Linear doesn't make sense.
Maybe length area.
Yeah.
Length,
That's better.
Yeah.
okay, is this also including when you're talking about labeling, using scales on graphs, or does that come somewhere? Or is this just measuring?
I don't know, I think this is mainly just measurement, that if you're running the scaling on graphing.
How is A different than also blue?
Pardon?
How is A different than also blue?
I think we take what's.
We're unpacking it, so it's kind of, this is
Okay.
the,
Good process.
so what we would do is, if I'm reading it right, is we would put a period here.
Yes,
Okay. And then delete this.
yes.
Is that correct? I'll take care of the formatting out of this. Okay, so convert units and systems within a system without conversion factors and between systems with conversion factors. Would we leave that in there now because we're talking about lead area capacity? Before it was just, so, okay, so from you, you'd like to leave it like that, okay? Put it back in. That's why I didn't take it out, because I knew that we would have some of that discussion.
I'm not sure what that means. I mean, I think that's covered in,
I think it's a good.
I think it's a given,
What's it
C
mean?
means, I believe what C means is they say, I'm not even gonna think about that, but so many miles per hour times blah, 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 so that they have to know that this rate, or this unit cancels with this one, but this one cancels with this one, and we know that that one comes out.
Or even like, just looking at the certification test questions, we got like, something goes so many miles per hour, how many feet per second is it?
I think that there are those multipliers.
Those are conversion factors.
What I don't understand is without conversion factors.
So they should know that like,
With-
there's 12 inches in a foot.
Yeah.
It's in the same
What did you
system.
say?
There's something that we won't give them, so like they should know there's 12 inches in a foot, or there's 3 feet in
Those
yard.
are given to them.
Oh, it's all, how, okay,
If it's in the
so
same
conversion
system.
factors given, I think.
I mean, I think those are all kind of covered in the ones above, but if you want to be more explicit, it's a matter of how explicit you want to be.
See, I think C is different than A and B.
I think you
It
can,
is.
yes.
Especially what I do.
Yeah.
Very much is the way.
And I will tell you, when I worked on this, I got examples from my niece, because you know, about medications, about weights, about different things, like so much per child, and then that's so many this weight limit,
No.
with so many cc's compared to this, and so she gave us examples, so they actually used.
I would get told like all this information, like, this is how many acres your field is,
So-
this is why you go 50 miles per hour, and they have to use all the units.
Right, but
That makes sense.
I get a multi-step problem, but I don't get that they're in different units.
Okay, Margaret, if you do, I'll try to think one or either answer you can, but,
Your conversion of Fahrenheit to centigrade, in order to do
No,
the
not even-
next step.
not even that.
So you can have two different things.
it's so many miles per hour, but it costs this much per.
Yeah.
That's not that's not within a system that we're converting. We're using lots of different things within the same problem.
The example that we used was that you're going on a field trip and so many loaves of bread, so many slices of bread per loaf. The kids have so many sandwiches, you know, that you have boys that are going to eat so many slices of bread, the girls are going to eat so many slices of this, and then, you know, we had a lot of long string of examples about how many loaves of bread you have to buy, and how many slices,
I have students,
lot of different things.
I have students who like, if you get an inch of rain on a football field, how many gallons of water is in it?
No, I totally understand the type of problem. I just don't get that from reading statements.
Okay, so how do
Maybe
you
it needs
work?
an example.
Okay, so I have to add examples.
I am getting
Right. You have an example.
And so those who did, you know, they or they just had to send us examples, we could put in there. That would be great to have tables of that.
And just a grammar statement in your first sentence above the page, put a comment after areas, just like areas,
Just a second.
second.
What'd you say you use this?
Right above the A.
Yeah.
There needs to be a comment after area.
Nailed it.
Yeah.
Say that again, please.
After area, the person.
That's it. What we decided is,
And again, those are things that I'm not gonna worry about, I mean, we're gonna say, but,
Right, but I
that
didn't
goes,
know
so you know that, you can take it.
Yeah, after label there.
Again, those are little things. that-
On B, I still think you need clarity about without conversion factors given or being provided, without conversion factors provided. Because I think there's a word missing. There are factors that need to be provided and given. Because otherwise, without conversion factors, it makes no sense whatsoever.
What about,
I didn't get
I guess what I read in that is made the assumption that it says without conversion factors, they're not gonna give us any between systems, they are gonna give us.
See, when I read, I thought I wasn't supposed to use conversion factors.
Right.
Because it says without conversion factors, so I think how should
I think
I?
there are units without conversion factors.
Understood, provided, and given.
Yeah, it's not worded.
And by the way, Margaret, this is the place where consider learning standards do talk about the scale and the graphing. Can you answer that earlier?
Yes,
Yeah, this is the place where they talk about that.
that's what I wondered.
So we might add a D if you want to do something about
yeah.
being able to graph it and interpret the scale of the graph in order to interpret the parts of the graph.
I mean, are you one by
So how would you like to?
How would I word that?
I'll tell you how it is.
Yeah, it also sounds worded.
Choose and interpret the scale and the origin in graphs and data displays.
Say that again, choose to
Choose and interpret the scale and the origin in graphs and data displays. I'm not saying that's what it should be, it's just what it is.
Well, let's put it up to starting point.
I think it's another kind of unit, those old problems, so I think it's.
I think it's right.
I think that's it.
Anybody, are we ready? Are we
I would
okay?
just apply and interpret, rather than choose.
So what are we doing?
Apply.
Apply and interpret.
Because you can't just choose anything, you have to
No,
apply.
the students choose the scale when they graph. That's what the intent is.
Oh, that, okay.
Yeah.
Yeah.
So they're choosing what, because sometimes kids have no idea of what
Whether,
a scale
whether
is.
one block equals 5, one block equals
Yeah.
Or whether it makes sense to use that whole area there. I think that's the intent.
Yeah.
Okay, if that's what they mean.
The idea is just that you're not always going to just do that for them.
Right, do we want it when they're constructing graphs and data displays?
I like that.
Choose and interpret the scale and the origin in the constructed graphs.
Constructing graphs, data displays, yes.
Okay.
Not interpret related to construction.
Or when constructing graphs.
Yeah.
You don't like that?
Well, they limits it to when they are only constructing it, not just, well, I see it interpreting, but it says when constructing. Interpret when constructing, it doesn't say interpret if given. I don't know how to word it, I don't really care. I'm just putting it
I think if you take constructing, if you go back to what it was, we did include constructing. I don't think it's specified, but, I mean, that is when you see gravel.
I guess you go right, that's
Opens both ways.
So to you, that seems like it's both ways.
Why didn't you take the word back out again?
Well, because you want them to be able to interpret the scale when the graph's already made. You don't want it to be just about when they construct the graph. You want it to be both when they construct and when they have one given to them.
I think what's causing us to hesitate here is because the choose is when you're constructing,
Right.
and interpret is when you're given. So.
Yeah, so it's almost,
I think you can leave it like this and go for the both. I think it's good.
yeah, but when you leave it like this, I think it's open to misinterpretation. Or it's not as specific as it would be if you,
You could be given a graph, you could be given a graph without the labelings on the axes, and you have to choose the scale. You're not constructing the graph, you're choosing the scale from some verbal description or from whatever.
Right.
So there are a variety of different ways that could happen, and yes, we want to know them all y'all.
Right.
And not that simple.
I think that's a good example, but I don't know, that's not choosing in the sense that they decide what it would be.
that would be an interpretation.
You know, it absolutely is choosing. If they're not labeled, then they have to label them.
But if they have to do it in a way that's consistent with the verbal description, then only one of their choices would be
Yeah.
correct.
That's why you're choosing it.
That's why you are interpreting in that particular instance.
Should we
No, they're not interpreting the scale,
let's
it's
look
not
at
there.
it and come back to it?
And I think,
But it says choose to interpret the scale.
I mean, you could say use appropriate instead of choose, and that would possibly.
next. And this is and I just want to remind the other team, we didn't leave it just like this is and get feedback from the survey and see if they talk about this is confusing to them, they're not sure what this means, or if you have some suggestions to clarify. But the thing is we really need to get this typed up and done and ready to have one by, to me, within the next week or so. So if you have comments, well, I'd love to be able to do it now, but I think that maybe we need to go on and revisit. And then if these things we have blue, we know this is where we can get back. Okay, questions about the board? Can you just give me an example? Well, when we're talking about appropriate quantities, is anybody going in that, you know, we're represented in context, I look at multiple things in one thing. I want to make sure that if I'm using area and some statements, I'm using cubic, volumes and cubic units of measure. Other
I extend it to context, like everyone concrete thing you guys should be.
Right.
Because of the context, that's how you order it.
Or, you know, those different types of things, it's appropriate for whatever you're looking into. So, I mean, we could put examples there if we think we need to, but when people read that, is that clear enough for us? Probably for you guys. Yeah, okay. And all right. Number 5, Bill.
That's good.
Yep, and then
business zone.
Well, I guess I do thought because it's one house. Excuse me, did you say something? Okay. Okay. Yeah, actually, okay. Interpreting and using structure. And this comes from, I think, seeing structured expressions, and that was SSE, so we can talk about it as a team if we want to put it as SSE or SE. I added on the blue, I think it was last night, as Rosa had brought up the other day about coefficients, terms, and factors, but I also think that, didn't we bring that up in the school? So I just want to make sure that, are you comfortable with Rosa then not specifically saying terms, factors, and coefficients, since we talked about that yesterday?
Is this in a real world context?
It says interpret the meaning in context, so I think it could be in a real world context. Do we need to put in context in the parentheses? Or
Yeah, I think that's to keep it consistent with 6 through 8. I think they could either be reworded or just take out.
So how would you suggest that you're talking about? What about contextual meaning? Is that the same thing? How would that interpret contextual meaning and individual terms and factors for a given situation? How would that correspond with what we've been doing to try to keep that flow?
Where do you put it? Moving context again.
Okay, interpret. So what you're saying is interpret the meaning of individual terms and factors in given situations that uses forms or expressions in context.
Or in real world. I mean, I guess scenarios, the real, you've been carrying through the real world.
So suggestions? Do we want to use interpret the meaning? Do we want to say interpret the real world meaning? So how do you want to say?
Contextually.
Yeah, may not be real world, maybe that.
Exactly. There in my house sometimes. Okay.
When I read number 2, I'm not certain what you're wanting there. Are they starting with things like 2x to the minus third, x to the fifth, y to the seventh, etc., and then they simplify those down and define like terms? Or what's happening in number 2?
I think there's a lot of ways that this could be interpreted, so that would be something that we would maybe want to come to conclusion in our discussion as an algebra 1 team when we were talking about limited, binomial, and triangles. So part of our thought, I think, the thought process, and everybody's in on this, was talking about rewriting, for example, x squared minus y squared to x plus y times x minus 1. You know, because you could talk about factoring, you know, x to the fourth minus y.
Okay.
So it doesn't specifically say factoring because it's limited to one thing, but it can be also for a lot of different interpretations.
Now you know what you mean.
Right, but it can be different things as well, just looking at the structure of the way some things are written. Nancy, you have a question mark in your face.
Yes, I do understand where you're saying limited to binomial and trinomial, but I also know that in algebra 1, I always taught something like x to the fourth minus y to the fourth was x squared plus y squared times x squared minus y squared, and then you had to break that down further as well. And that really limits that.
Okay. And the suggestion was made by our team to limit the binary.
Yes.
But I'm open to
And I get what you're saying, and I get that maybe there will be some limit, because I think there was also in the survey standards under APR when it's talking about the operations on polynomials, addition, subtraction, multiplication. It says something about limiting it to, I think, a certain degree. However, boy, that's really limiting. I mean, it is limiting. When you just take, you can't go up to, yeah,
polynomial expressions.
No, actually, what I was saying will fit in this because it's a binomial.
Yeah, it doesn't even fit,
Right. But there are times when we're saying that we can't take anything and multiply it by, we can't take a trinomial and multiply it by x,
So,
x plus 2, because we'll make it into 4 terms. Do you know what I'm saying?
Yes, I do.
And I don't know if that would even fit into this one, because this is about the structure and rewriting. But
well, and so shall we take that and do?
I can see more if we're looking at some kind of pattern thing we're going to develop. We may get several terms when we're looking at the pattern and developing that way. It might condense down to a binomial term, but it might not be there.
But you have to work with the bigger terms to do that. So,
Yeah.
maybe,
Well, Julie, I'm going to do it for I want to provide that next to be a big portion of this course.
Yeah, because I didn't even do that.
What's the date of the
Dave, what are you saying arrive at the binomial trinomial? Because that way you can have the more complex ones.
Well, if you're starting to complex, it might go down to that, but what you're factoring, you're going to get into.
Factor out your greatest common. And then you also go back to, and I'm not sure we do this much anymore, but where we have a perfect square trinomial and then another square, and then we factor the perfect square trinomial, and then we factor that down to, we might have x plus 3 y squared minus y squared, and that would be x plus 3 minus y times x plus 3 plus y. But the question is, do we do that in algebra 1, or Julie, is that done in algebra 2? I mean, I think there are things that we need to be careful about putting too much in algebra 1, and limiting it to a certain point and going really in depth rather than doing too many different things. So we could talk about factoring here, we could also expand upon that in algebra 2, because the one thing I'm concerned about when I say limiting the binomial and trinomial, I don't want to factor the sum of difference of cubes. And that's quite a bit more than I would expect it to be.
So is the question leaving it as polynomial?
Just leaving it as polynomial expressions in order to rewrite the expression in equivalent forms.
I think this is the place where we need to have A, B, C, and D, where we list the factoring forms that they're expected to do at this level. Because everybody's talking about factoring, but it's not clear when we read this, that this is factoring.
But it's not, but it's, I think it was being, I don't necessarily think it's just factoring. That was an
And
example.
that's the mistake that I made, because I was reading it as factoring, which is why I was like, well, we don't factor a whole bunch of different polynomials, we basically binomial trinomial. But when you brought that up, then it's also going in the direction, and I agree that it shouldn't just be limited to that.
Well, as far as this is concerned, this could be something like just writing a simple interest problem and understanding what the, you know.
So we're talking about interest. So we're talking about interest problems, and we're not talking about necessarily just factoring. So we might take polynomials out there.
Well, I think you need to have examples of what you're meaning, because when I read that initially, I didn't pick up on factoring. And my mind went somewhere else of how we're going to analyze.
So what do you
Come
come
back
back?
is coming in somewhere else.
It does.
And that's-
Yeah.
So it's not
I
like
think-
why it is yours, though. So,
Yeah, that's what I'm saying.
so Penny, tell me what you were thinking now.
When I read that initially, I was thinking that it had things like 2x to the minus 3x to the fifth y, and a whole bunch of terms like that, and then you had to simplify them down individually, combine those terms that then turn into like terms and write it.
That's what I read.
Okay,
Is that what you read it to be?
Yes, not a factor.
Yeah, I didn't touch back.
I think that could be a part of it,
But I didn't touch that the way it's written. If we
Okay.
wanted to be part of it, I think
But what you just said, 2x to the negative fifth, those things, then that's not a polynomial, right?
well, when you combine it, you could end up with,
Somebody say good.
it could, you could have like 3x to the third, y to the second, plus 2x, whatever, and you would have a polynomial.
So how do we rewrite this?
Well, what I wanted to say is to address what Mandy's saying. Mandy, I believe what you're talking about are operations with polynomials. And that is addressed in a different standard here. It isn't really labeled, but if you go under C, and then you go down to one, or I'm sorry, then it was D, E, and in the last cell, see that add, subtract, and multiply polynomials and understand? I think that's where that type of thing would happen.
Yeah, but my thing was, is when I read that, I wasn't clear what the standard was, and I think we have to make it so that when we read it, you know that it's involving factoring or whatever it is we want it to involve.
When you say in order to rewrite the expression in equivalent form, that's almost, to me, that means factor.
Well, I guess I see this tying more to one, that we're just talking about the expression. Simplify it, you can't simplify it, you can't, it's just, it applies to a whole bunch of things.
So here's the question, should we put, do we want to limit it to polynomial? Now, the polynomial there.
Oh.
Yeah, do we want to limit it to polynomial?
Well, I had two things I want to say, so sure, yes, I want to limit polynomial, and if you want to figure out cubes, limit the degree as well.
Yeah.
And then, but my other thing, and this is admittedly not very imaginative on my part, but for example, what I thought of when I see that is a completing the square-like process where you sort of rearrange it, and I suppose factoring is a player in that, but certainly not the only player.
Exactly.
To rewrite it, to see the vertex. That was what and I realize that's in there somewhere, but when it's analyzed the structure, so I didn't see it as being limited to factoring.
Yeah,
But I would.
my concern is that, I brought up the example of factoring, and maybe that wasn't the right example, but there's a lot of different ways, things that it could be used for. So if we want to leave it as polynomials, I'm fine with leaving it as polynomials. But I really agree with what Nancy had said about taking out limiting the binomials and trying to move to us then limiting it. Nancy?
Well, since it's so confusing, and we said we have the polynomial operation somewhere, and we have the vector somewhere, do we?
This is about interpreting the structure of the way it's written.
Right.
So it's about, if it's written this way, what can I pick up, like Julie was saying, can I pick up the zeros, or can I pick up the interest rate, or can I pick up the, and rewriting it, that's what this is supposed to be about.
Well, I think it was simplified because we wanted it in an equivalent form.
Right.
Because this is about seeing the structure of it.
Right.
Then maybe we
How's it connected to whatever?
dial down the rewrite piece.
So say that.
So if this is about seeing the structure, maybe we dial back the in order to rewrite so that that doesn't become the focus.
But I think it is the focus to rewrite it or to get an equivalent form, or could get an
Well,
equivalent
and I think that sometimes, I'm looking at problems if I want to solve them. When I look at problems and I want to solve them, sometimes when I'm analyzing the structure, I'm like, okay, this is what I want to get. Kind of like Julie, what you were saying with completing the square, maybe that would be another example. I need to have this, so I'm going to add this, and I'm also going to take it away. So I'm going to rewrite it so that it still represents the same value, but I've now rewritten it so that I can use this process. So the structure, I need this, so this is what I would do to get to be my answer in the form that I need it to be.
And maybe a better example is if you have a linear, then you rewrite something, if you could be given, two factors showing the roots, or maybe one root, and then when you multiply it out, which would be a different form, and then you could see the fixed cost part of, I have no imagination on this, but this is what I'm coming up with, but just, you're focusing on different parts of, and I did the dots.
Yeah, well, you just said it in complete and square, we do that in all kinds of graphic situations where we take an expression and we rewrite it. So we see the center of the circle, we see the vertex or whatever, yeah, it's very important to see that.
And those are kind of eighth gradish things, the aerial down one, but this is supposed to be for, I think, linear, exponential, and quadratic,
Yeah.
So do we, but if we put linear and quadratic with it here, if we leave polynomial expressions, then exponential would fit into this. So do we leave this as polynomial?
I think everybody's saying about the same thing, so maybe a decision by the team.
Okay.
So I would not include exponential.
No.
Yeah, I think for algebra 1, I would leave
No.
team decision. Okay. All right.
We're on to 3 already? Say, so.
I see factor form there in 3A, but I still don't understand what factoring forms we expect them to know at this point. I still don't see a list. I don't see factors. I don't see trinomial squares. I believe we need to lay out which factoring forms we expect them to master. I didn't say anything.
Why? Who's asking?
Because I've seen too many students who come through Algebra 1 and Algebra 2 and still don't recognize the trinomial square. Well, and I'm the square majority. But remember that when they do complete the square, that is the emphasis in here that they're going to have to go through. But then in order to complete the square, they're going to have to recognize what a perfect square trinomial is. So, I mean, we can start listing it, but when I say in factor form, I'm assuming everything. I'm assuming that that I can factor the difference of 2 squares, that I can factor any trinomial, whether it's a perfect square trinomial or not.
Maybe that's a term that they're on.
It seems like that's one of those things that, I mean, there's other things we can start making lists of too.
Right.
My assumption is anybody teaching algebra 1 knows the factor, the normal factor and things that we do. I mean, any teacher.
And I know, Rosa, I know what you're talking about. The kids come out with, my biggest concern is not that they know all the forms, but what I think the fallacy that we have is people just teach the drill and practice, and they don't teach an understanding of what it is and relate it to an area model or relate it to different formats so that the kids have a strategy to use later. Too many people just teach it to drill and practice, not enough relationships, so they have nothing to connect with later. Because I taught Algebra 1, I taught Algebra 2, I taught pre-calculus, I taught calculus, and they still had issues. Okay. But also it was because people didn't use the hands-on models, didn't use a visual approach to do anything, and once they did, and they made a connection, the kids had something to fall back on. So I agree with you that kids have trouble factoring, but I don't know listing the forms would make a difference.
But we've already said that we don't expect some different cues to be in this course.
I would expect that to be in.
Quadratics, exactly.
Yeah, that takes that out.
So this is under quadratics. So this part is under quadratics. Okay. Yeah. So it says expression find zeros of the quadratic expression by rewriting in factored form.
That's going to be my question, why we don't have exponential things in here.
Well, and this is from the standard itself that we took. So that we took from, I think, Georgia, that we modified. So if we want to put that in, we certainly can.
Well, I don't mind it being changed. I'm just saying that in the current Missouri Northern standards, it does talk about properties of exponents, transform expressions, or exponential functions. And then it gives an example. And so if we want to leave that out, I understand. I just want to make sure that we're
Taking that out. Because this is, we kept in just what was quadratics and we didn't exponential, didn't have anything in there dealing with exponentials. Do we want exponentials back in, and that's fine. Team, as a group, what do you want to put there? What do you want to do?
tell you the example we did. The expression 1.15 to the t can be rewritten as 1.15 to the 12th quantity to the 12p, so that you can reveal what the annual percentage rate is. Blah, blah, blah. And I don't know if you want it in there or not.
And I know when we looked at them, and I got some feedback and a lot of feedback, people didn't want the exponentials in there, but we can certainly put that in. Georgia had taken it out and used it
So will we address that somewhere?
I don't think it's
If we
just.
didn't add that to object, but that's an important thing,
Yes.
that structure
I'm
is
not,
important.
I'm not disagreeing with that.
And as of right now, just looking at size of number of things we have in Alpha 1 and number of things we have in Alpha 2, a lot of stuff in Alpha 2.
So can we make note?
Yes.
Because I don't want to overlook.
Yeah, I wasn't saying that it needed to be going completely, but I don't look at it now. And you're right, no, with my experience, I don't.
And they don't want it.
So are we okay with leaving this as it is, and then putting that exponentials, looking at the structure of exponentials in algebra
Of course, we talk about exponentials just in the next couple of years.
Right, when you get down to, I don't know my number that I'm looking at here, but, you know, create equations and inequalities, and you have exponential functions, integer inputs only, and I have a question about that, so, I mean, I don't necessarily think you have to answer that question the same way that we answered the one we should have answered. However, that's bugged me, and I have not, you know, since exponentials were sort of put in Algebra 1, I haven't been teaching Algebra 1, I don't know how that, you know, looks from a teacher standpoint, but that integer inputs only and creating this, you know, discrete function just bugs me, and I just don't think that way, so that's my comment.
No, and I'm fine with taking that out, so. And I, you know, in teaching algebra 1, using exponentials, most of what we did was with integers like we would, you know, you have 2 to the x, and we would usually have them plot graph, where they would input the integer values. Now, to make it continuous, we would talk about there are those parts in between, but we never expected them to graph 2 raised to the 1.5. You know, we expected to graph 2 to the first, 2 to the second, 2 to the third, but we never expected them to graph.
To find a
Right.
Right, and that's where, you know, I just think you get super confused because, you know, you might not want them to plot points with integer inputs, but do you want them to, you know, make the assumption that the graph is a continuous curve, or you want to end up with a discrete function? And I have seen it in, like, PD things, I've seen it explained both ways, and I never got further than, not my problem. So,
The reason they do that here is this is the student's introduction to creating those equations. And so they wanted it as a pretty basic thing. I get what you're saying. I hope teachers will relate it to real life. I had one other comment on creating equations to describe numbers and relationships. I would hope that we would define there that it's about linear, quadratic, and exponential. So, because it's algebra 1. But if you don't want to put it in there,
Are you talking about the header right here?
yes, ma'am.
I've got a
Should have commented on that.
on that one. Create equations that describe numbers. I would have rather it said describe number relationships, because you don't have an equation just to describe a number. You are relating one to another.
So you were saying maybe
Create equations that describe number relationships.
or just about relationships?
Yeah, I would prefer to take that.
And would it be okay if I took that out?
Oh, sure. Either way. But, you know, when I say number, when I think of number relationships, I think our club, not club, has all these different jerseys, like, and they have a square root of 2 plus such and such. You know, so and ending up with something that would be a 5. If you go through the mathematical steps, and so to me, you are relating numbers with like that.
I think this was my interpretation, but I hear what you're saying, that the numbers was to go with the one variable stuff, and then if you're going in 2 or more variables, then it's the relationship. But if you have the equation in one variable, it's kind of describing a number. If you're getting to a
It's
number.
not a relationship between numbers.
Right, and I think that's what the intent was there. It's about a number, or it's about a relationship between two quantities. I think that was the intent of that letter. If,
Yeah, because the very first thing says equations and inequalities in one variable.
Right. But it's one variable, yes, but it's a relationship overall with it. I just, you know.
An equation in one variable is a relationship between what?
It's a relationship, but you're not describing a number.
Not a number, no.
I heard it implied on number 4 that you wanted those to be solving problems in context or real world problems, not just, I mean, you're not going to create it unless you have some context or real world. But you're not just to solve it. I think that needs to be a much better unsolved problems in context or real world problems, just all real world problems. No, yeah.
4 here.
Yes.
I'm using to solve problems.
Real world problems.
Solve real world.
I think, don't go off that one until that's resolved, because I really think that you can't have equations describing a number. It has to be a relationship.
X equals 4. So, well, that's the equation, describing the number. What about if we create equations for linear, quadratic, and exponential?
That's the answer to this one.
What about if we took out, here's somebody made a suggestion, create equations for linear, quadratic, and exponential functions? And take out numbers, describing numbers or relationships.
I think you're limiting yourself, because I think the teachers are just going to look at it and say, like, you're the okay, just stop.
Let's just keep it crossed out, but keep it there.
And then we just Great. I'm going to change color. Okay, so I'm going to change color. So we don't come back and change this scarf. Yes, so are we okay then, do we want to take out integrations or do we leave or alone? So where did it fall? Leave this as
algebra 1,
and I'm not teaching. Right. I think when you go out, you do that changes, right? Okay, watch. Big, drugs. Was it? Which is right already there in outside, but we're not pushing. We had it later on in our discussion, but that, so we didn't add it to that. So discussion team, I think we look at some of the other states and what they did in these clarifications.
Were you going to put real world in there?
I thought I did.
No, it is.
That's right.
Did you put to model real world problems instead of just solving? So that we get the modeling.
Well, do we want a lot of editing?
well, this is, no, I don't. I think it's not always about modeling real world problems. I think that's the problem too, it has nothing dirty on that, but I think it's just about teaching algebra kids to create equations that are linear, exponential, and quadratic. It's just as to do that. Sometimes they're real world, sometimes they're real crap that the teachers up there. Sometimes they're new problems, they're there.
Could they say exactly the truth? Could we say in context? In context or something?
Okay, sometimes they are, and if you want to put that, I don't care, but they're not always real world problems. They're not.
So,
I think that's what it's about.
Okay, so from the group, and Julie has you guys model and solve real world problems. Do we want to leave that and we change that, or do we want to leave that up to the Algebra 1 team to make a decision?
I think if you would include model, that it lends itself to context or real world. I'd be okay to model itself. Because I think you're going to model a scenario. And take out the word real.
we were saying model and solve problems, would that be okay? So that should be a pure mathematical problem about a real world context.
It would help me.
Nancy?
I wouldn't get that in the way it's directed, but I'm cool with it. I wouldn't get that.
You wouldn't get what that means.
I wouldn't get that it could be a naked problem from that sentence.
Because you're thinking instead of use them to solve problems. Prior to this, we had saying use them to solve problems.
What if we said and or?
That's what I'm thinking, would model and or solve problems.
You did that.
I do think the vast majority of what some of these teachers.
Model and or solve problems.
Because the purpose is really here for them to create the equation. It's not for them to necessarily solve it. That's what CE means about is creating equations.
So, are we okay? Can we live
I
with
is
this?
so
Say-
fine.
Can we live with this? Okay.
Are we on to 5 now? And they're not going to do quadratics here.
That was what he does, you know, and we can certainly do that. Create linear and simple exponential equations in 2 or more variables. No. And so that was when we said 2 or more variables, I was a little concerned about 2 or more.
I'm trying to think what that would look like.
And so I guess there are 2 things on the table here. Do we want to create linear, quadratic, and simple exponential equations in 2 or more variables? Nancy brought up that quadratics was not here. And do we want to take out in 2 variables, or we want to take out 4 or more variables?
Or just tell me where you're creating the quadratics. Where are you creating it? I'll tell you the area of it. Tell me the area.
I know where it was originally, but I'm not sure it's still there.
Okay.
So Nancy can make that as a note, and then let's put down here, quadratics. We'll put a question mark in, make sure that if it's not addressed, that we put it here.
Well, I do like the idea of, you know, the comparing the linear and the exponential. So I don't know if I'm making a suggestion of putting quadratics in a different space, but I do like the idea of comparing linears and exponentials for sure, and that is something kids can do.
In terms of a discrete one.
Quadratic equations comes under, I think, ABC, as it is in this document. I don't know if it's all that you want, but quadratic is mentioned in the next section.
Yeah, it doesn't say.
It doesn't say creating, it's just solving.
And I think part of that is people thought it was easy to create exponential, and it's easy to create the linear. It's a little bit more complex to create the quadratic, although it can be done.
Some quadratic, but not all.
Right, some simple quadratic. So
So
we
we're listing
Area
that.
square.
Makes sense.
That's
Yeah,
simple.
Nancy's example is a good one, but.
Maybe you should say simple quadratic.
So create linear and simple quadratic and exponential equations.
I don't know about those more variables. Do you need more variables?
I don't think so. I think
Yeah, I
linear
don't know what that would look like or why you would.
Yeah, I think,
I
yeah.
wouldn't want to dealing with it.
I know, I just don't want to think about it.
Create linear and simple quadratic
Not the same as actually like,
and exponential equations. Two variables.
I think it would be more.
So then you want to do linear, comma, simple quadratic.
I would take out the quadratic with question marks.
Yeah, I have a problem. Are we okay with that? Okay.
Simple, plus quadratic.
Yeah,
So,
no.
and some quadratic.
Yeah, just simple ones to go.
Put them in the brackets. Okay, 6.
I'd like to report, I have no comments on 6.
You have another?
Note the time, please.
At 10:05, right there, here's the other comments. Okay. I have a comment on 7. To me, for a specified variable, the kind of the quantity of interest was redundant. I would just say for a specified variable. Kathy explained to me that we might not be necessarily solving for a given letter, so I would like to see an example when we talk about was solve the formula area equals L times W for length, so students would have to know what they were solving for given the quantity, but not necessarily given the letter. Because all we're going to say is solve the formula A equals L times W for L, then we don't need to say the title of the quantity is, we just specify the variable. So I would either say take out the highlight the quantity of interest or give an example of what we need. Something like that.
To take that highlights of quantity of interest, so you're saying?
Yes. Yeah. That's what I would have done, but if what we need is this as an example, I think you see why we need that whole
They
thing.
can specify, I think it is of interest. I mean, I think the word specify.
Solve the equations and formulas, and so we say solve the equation
For a specified variable.
Here it is. Okay, sounds good.
Well, you could, but you know, your quantity of interest could be a compound quantity, I mean, it could be made up of more than one variable. I don't know if you want that number one, but I think logically that would have been a difference.
And I couldn't do what you're saying.
Sorry, so I was just saying, and this is not a big deal to me, but the difference logically between leaving it out and putting it in is that when you have it in there, you could be suggesting that you focus on a quantity of interest that might not be a simple variable. It might be a compound,
It might be a quantity.
a quantity, yeah, you know, PRT. But I'm fine taking it out and fine with that variable.
I thought I.
So we-
How about that I put this in red? Because solving the literal equations would be one thing where they give you the formula. And then the others would be special variable work, could be in words, or it could be something specific. Or, but a quantity of interest, you are right, Julie, and I guess what we have to make the decision is, do we do that in number one? Or is that something that we take to the next level in algebra two?
I mean, if you were going to solve for R, that'd be harder than solving for PRT, right? So, I mean, you're not necessarily making it harder, but you might be making it more confusing for teachers and to what advantage really, so.
So here's my question, do we want to take out that has a quantity of interest and have an example after that? Or what's in red, do we want to eliminate or do we want to leave there?
I'm trying to do right. I meant to make that.
So when you say highlight quantity of interest, giving the example, tell them what that means, so that if they want to do something else, they can. It doesn't matter. I'll leave it in there.
Right, I just thought having it in there leaves open the possibility of a compound. So if you don't want to force that, then leave it out.
Okay.
Take it out.
Take it out.
whatever we will have to make some decisions on as a team. Okay. And C, I haven't started putting the code here. I'm just going to start labeling these as 8, 9, 10, so you guys can talk about those. And I'll put the rest of it in line.
10 to 9.
No, really? No, it's,
What about twos?
yeah. 2s and then 1s, then 2s and then 1s. Let's see if that.
I'd like a, you know, question mark on the word justify, whatever, you know, whatever verbs we think we like, you know, I don't know if it's a verb or whatever it is. But I like the idea of including that.
Demonstrate, yes.
I don't mind justify, I just thought when we talked about, you know, that.
Use the word demonstrate instead of justify.
How are you going to do this?
How are you going to justify?
I was thinking, there, several of the boys I was thinking about, and I read ahead, that justification would be with properties, with various things, you know, I was thinking about various properties.
See, and I was thinking of substituting that.
Yeah, that's what I thought.
Now to demonstrate,
No,
but I can also justify.
I would too.
And I don't hate to justify.
Yeah, no, I am too.
I think that's.
Because I think justify allows both ways to do that. Demonstrate to me only says I put in another.
I think if you can have something that can be interpreted two ways, it's best to have it so it can only be interpreted one way.
Actually, I think do something on
Yeah,
one
well,
case,
what is-
Then specify the two ways, otherwise somebody will.
No, there may be a third way that we're not thinking of.
The thing is that if kids come outside the box and able to justify it to me in a way other than what I was thinking about, I want to leave that available only to people do that. Because when I limit it, and I tell them they have to do it this way or this way, then I'm very limiting. I want kids to really think, I look, my kids, I think we stymie the kids that think outside the box. As long as they have really good justification.
If they can demonstrate it, it doesn't have to be only just one way. How do you think demonstrate limits?
Because justification could be not a demonstration, it could be a application of properties, which is not really a demonstration. It's just like doing a proof. When you do a proof, each step is not a demonstration, it's a justification. The reasons are the
There are
justification.
reasons there.
Right, that's what I'm saying, that's not a demonstration. I don't think it's a demonstration. It's just.
I think I can justify it with, using properties, and I think I can justify it depending upon the context that I'm in with substituting in numbers and showing them the same. So my feeling, and it's up to the group, that justify was a little broader and allowed a little bit more flexibility than just the word demonstrate.
And I'm going to justify on just my favor.
Is we got, I mean, can we leave it as justified, and do we move on, and move that to black? Fred, I'll tell you what, why don't you think about it, and then send us some suggestions, because you're on the actual one team.
And can I just make one more small comment before we move completely on? And this is a question. Do we think a teacher would think that justify means something a little more formal, or maybe formal is not the right word, but Nancy and I were thinking substitute in, there you go, we've shown that it works and it justifies. Would a teacher think that that means you have to talk about properties or?
I think that's a great thing for when we start talking about mathematical practices, because one of the common core ones is that we construct liable arguments and critique the reasoning of others. And I think that's part of the way there needs to be something in this document that talks about that idea of justifying, I think that's part of the description of that.
And it's used sixth grade on up too. Actually it's used in elementary currently, but we're not a new concept and what justification is.
So if we substitute in the third or fourth iteration of our problem and it's true, and then we go back and we substitute in the original iteration of problem when it's true, we justified it.
You'd be justified.
Okay, well, if that's clear, then I'm happy with the way it's written.
Okay, let's look at, solve method and rule of problems along quadratic equations in the numeric. Use the method of completing the square. The reason the word, A is in blue is because originally that was any, and I think it was Tiffany that said she had a little discomfort with saying any quadratic equation in X to an equation of the form X minus 2 pi squared plus B, but we can change it back to any just for the good of the group. And then it said derive the quadratic formula from this form. And I guess the question that I had when we had to derive a quadratic equation from this form, quadratic formula, I'm looking at, right now, this is a linear factor. That's we would only be deriving the quadratic formula where the coefficient of X is 1 based upon the way that form is written. And that was the issue that I had. And so my question is, do we derive the quadratic formula for just this form, or do we want it more generic? And so that's my question.
So you're asking, do we derive a special version of quadratic formula where A is 1?
Well, and what they're saying, but what it says is derive the quadratic formula from this form. So I think they're not thinking of a very simple format of the quadratic formula. They're not thinking of what we traditionally do, the x squared plus bx plus c. They're thinking of a simpler form, which, to be perfectly honest, in algebra 1, I'm kind of okay with, as long as it's done, taken, expounded in algebra 2. But I'm open for suggestions on that.
So do you complete the square for
Says using
quadratics where A is not 1?
Well, and that would be, like when it said any form, that's what we said, a quadratic equation in X to the form, when you said any quadratic
But
equation.
this doesn't prohibit
No.
that, because Q could actually be something over A.
That's true.
So I don't think,
Q
now,
could be
maybe we want to be more explicit than that, but I don't think this prohibits developing the quadratic formula for A squared plus B and plus C. I don't think it prohibits it now. That might not be clear to everyone, but
And I think that algebra 1 students should do the full-blown quadratic.
I do too.
And I'm fine with that.
Why not?
Well, I do not want them using the quadratic formula to solve equations without knowing how to derive it where it came from.
I want it to rhyme, but I don't want it with a coefficient 1 on A necessarily.
One of the questions I had here was, should this be a separate, should that be divided into two things?
So on A.
So in other words, you want to use the method of completing the square to transform, and I would say go ahead and solve. Use completing the square to solve, right? Because that's what you're going to do when you do derive the quadratic formula.
It wouldn't be, this is, I would like to derive the
So that would be like a B, derive the quadratic formula.
That's what I was thinking, maybe.
So should we just say, like, make this a B, derive the quadratic formula, period?
And you might want to even say, for quadratic equations such as A, in the form A squared plus B equals C equals 0. I know we all know that, but just so we're not confused about whether we should have an A there that's other than 1.
Okay, and so I'm going to go back and format this later, AX, because I'm just doing it from the X squared plus B.
Where A
Make
is.
more sense to do that before you do A.
I don't think so.
No.
Because that's just transforming.
No.
That's just transforming. And then the other one is, there's a lot more involved with
You
it. So
can
that's
do A
just
before you
right.
do B.
Yeah, you can do that. And so derive the quadratic formula, and I'll do more formatting with this later. But
And you may want to say where A, B, and C can be, what do you want to say? Can be any real.
Do you want to put the integer?
Yeah, you want to be any real.
I think we want, do we want to be, I guess we can have 1/2, but we'll leave it any real number. I think it's pretty complex.
Well, I mean, you're deriving the formula for any real number.
Right.
Man,
Eighth graders can do that.
I did it too.
For decades, my kids did.
Well, I'm sure they did, but I can tell you there are a lot of people that didn't, but I agree with you, Nancy, we need to push them, especially with the foundation.
I'm just saying this is a standard of an Algebra 1 student to be able to do that. And my answer is yes,
Yeah.
whether they're in 8th grade or in 9th grade.
Okay, so I am going to highlight this and be So we'll, the alpha team will tweet that.
We have to see. I would just like the verb, the quadratic formula. Is you're taking square roots, you're completing the square using the quadratic formula.
And use the quadratic formula?
No, B
Parallelism, completing, using.
yeah, taking, completing, using, and factoring.
Yeah, put a comma after formula.
Yes.
I'm sorry, I can't hear some people what?
Put a comma after quadratic formula. Just to be consistent with
Maggie was a proof of it.
Well, and that's the big thing, is that we need somebody that's going to be able to improve the algebra one, improve the geometry, to make sure all of those things are taken care of, so. Okay, we're ready to move on to 10. Because there's some discussion that we had on 10 for some clarifications. So, we don't need the one. Yeah, she's gonna start, yeah. Well, that's why I struck that, that's why I struck that.
Watercraft song. Either way, that's good.
Okay?
So this is double, what's on top?
Well, this group in at which I think everyone has something to say.
We need all this.
Yep. Because it's talking about solar systems. So,
This one.
this 10, I don't think it's the actual solve. Well, you could, what do you guys think?
I don't know.
Let's go back and look at that. And remember, the headings that I did were really quick last night, so I have 9, I didn't complete them all, so.
And the Missouri Learning Standards was correct.
Yeah, that's what I was thinking it was. So I'm just gonna say move below, I'll just type this in, move below solid systems. Solid systems of linear equations, both algebraic and linear.
You need both of them, it's fine with it.
I think so.
Yeah.
Because I would be concerned about some people doing it one way and not the other, so. Although
With an and that implies both.
yeah.
Oh, you meant we use the word.
Do we need the word both?
Yeah.
Because it's redundant, basically.
So, Maggie, how would you change?
I just say both that way.
Algebraic, so, yeah, fine. Solve systems of linear equations, algebraically, graphically, or, is that how, okay with that? Okay. And we're going to do the same thing
Yes.
And you and I talked about the fact that graphically it's an approximation. Do you think teachers know that it's not an exact? That when we solve it graphically, we really haven't necessarily found an exact answer? I think they talk about it, because we talk about it, we need to put that in there.
Show it, graphing calculators very easily, so.
So we don't need to put solve exactly, solve exactly. Okay. Doesn't number 16 go back under A? Isn't that interpreting the use instruction? And I don't know if it's to me, and I think it's really not belonging here because it talks about, because we had talked about that, this was an add-on.
and it's about operations, adding, subtracting, and multiplying polynomials. So can we go through 13, 14, 15, and then we'll address that question? I know you're right, it doesn't really belong here, so we have to decide where it goes. So any issues with 13?
I have could I address the E, just heading?
Sure.
Do we want to limit the kinds of equations to linear and exponential? And the only reason I keep saying that is, I think one of the things that's so confusing about the Missouri learning standards is that when an algebra 1 teacher would open it, they didn't know what type of, and in algebra 2, they say, what type of function or what type of equation am I supposed to be talking about? So if we can define that in those headings, I just think it would be helpful.
So 13, okay? $14? $15?
I think I did that question. This is about I guess my question is, and maybe I should read one carefully, how does it differ from 11 and 12? Is it inequality? And are we going, do we want a linear exponential? Or a linear quadratic or a...
Well, and that is the question, do we want them to graph the quadratic inequality? Julie, shake your head no. So is that going to be done in algebra 2?
We do, in algebra 2, we
Do you address, is that addressed in the standards to graph the quadratic inequality? I mean, I know that teachers are normally do,
Yeah.
it's not specifically, is it, if we need to make sure.
I know they'll have it
In Missouri learning standards, it's only linear.
Yeah.
we have it.
Do you have a
Specifically looking for a graph? Oh, and represent graph? No, we don't. Here's a question that Tiffany just brought up, is solve systems of linear equations, or linear inequalities.
Yeah, that and algebra 2, systems of linear.
I think it, well, I think it's not.
I think you do too, yeah.
So, I'm going to insert from.
No, I think they have it in algebra 2.
I think it fits in algebra 1. I think it really, I think, do it have traditionally done it in algebra 1.
Systems of linear inequalities is in 1.
Yes.
But we left it out of this stuff.
Yeah, it's not in there, so.
We have 2 unknowns instead.
Well, it's a system that has to do with two. You can take it in algebra 2, 3 dimensions if you would want to. Okay, so the new 16, this is a, who are you? Do we want to graph systems of linear inequalities, or solve systems of linear inequalities graphically? Okay, so solve systems of linear inequalities by graphing. And Julie, I would think that in algebra 2, that you would not just be linear, you have linear to quadratic, linear, that use linear to quadratic, linear, quadratic. Yeah. So, okay, and then Rose is absolutely right. So are we okay with 16, the way it's working? Yeah. Okay. When we look at our question mark, we'll figure out a place to put it, a better place to put it. Add, subtract, and multiply polynomials. At one time it was in here and divide polynomials. We had and divide polynomials by monomials. We took the divide out, but it certainly can be put back in because it brings up a little bit of what Maggie talked about when we had x to the -5. Well, that could be when you're doing the simplification, and the question is, do we do that in algebra 1 or do we really extend on that in algebra 2? But what's the thought and feeling? I certainly don't want to get into long division polynomials. natural one. I think that's beyond scope of what we want to do. I would not object to polynomial divided by monomial for them to know.
But I think that is because
Right. But that the group, I mean, I do like that how South Carolina put in there and understand that they're closed under these operations. And I like that we have polynomial, yeah, and I like that they have polynomial plus polynomial, get multiplied, and when you add an addition in there, then that changes that, because then it's no longer closed. So, do we want to leave division out?
Well, yeah, I mean, the way you have to talk about there with your closure, yes, but then put division separately. Now, you do have them pull out a greatest common factor, in other words, a monomial greatest common factor. So when you do that, isn't it pretty easy to say, you know, also what that says is that this divided by that is one of the other ones, right? And I guess rewriting that idea, factoring out monomial as a division problem. I mean, I guess I'm just suggesting, I don't know how difficult it is to do that. We definitely did polynomial divided by binomial in algebra 2.
Right.
So, and we certainly wouldn't do it before, you know, that. So we'll have that conversation.
In algebra 2, when you start looking at your rational expressions, is that where that happens?
Dividing polynomial by binomial.
Well, even a monomial. I mean, could be.
It could be.
Yeah.
Yeah, I mean, we didn't say that specifically. I was thinking that that was going to be done in algebra 1. I'm fine if it is or if it isn't, but I just thought, you know, well, you're having to factor it out, so, you know, I mean, it's, in my mind, that's equivalent to division.
I think it would be, there's one of those places again where I would say, we have a lot of stuff that has to be one.
Yeah.
That would be okay. Yes, you're all around it, but
But you don't have to do it. It's fine.
So are you saying not dividing the polynomial by monomial is okay, not to do it on one?
Not by monomial.
I personally think that you can divide a polynomial by a binomial if it's a factor. I mean, it all fits into the factoring and showing them when they're factoring and when they're multiplying a binomial by a binomial that it's the multiplication division relationship. I don't do it when there's remainders, no. And certainly by monomial, they need to know that because that's how they, I mean, think of the quadratic formula. What if it comes out there, then you pull a number out and rewrite it or reduce it or whatever you're going to call that. Those things happen in algebra 1, but they happen as a course of everything else. It's not that, oh, I'm going to set aside a week to do this. It's part of those other things that you're embracing.
Yeah, I don't think it's going to add any time to put polynomial, dividing polynomial by polynomial. I don't think it's really going to add.
Well, and the answer is going to be that dividing dividing a polynomial by a binomial that is a factor of the polynomial.
Yeah, and I'm not pushing that it has to be, but I think that's certainly part of it. That's
sure. I'm just afraid if you put that in here, that it's going to be, okay, we're going to spend days doing division of polynomials.
Well, McFly,
Well,
you know,
I think those are good conversations to have, but I don't know that I think that polynomials by binomials need to be
In terms of a standard, I would reserve it until you actually got an algebra. You're going to be, it's a part of the thought process and how a teacher goes about doing that. But nevertheless, let's leave it as a standard until the next class.
So this is, I guess this is what would be potential for assessment. Doesn't necessarily mean that you can do that. I'm sure I understand this.
And I think they are good.
So do we want to put in the divide polynomial by monomial and leave it at that, because that could be the greatest common factor. And then I know we can bring it up, and I think maybe when we get the survey back, people might ask, what about dividing it by a polynomial by a factor of a polynomial? So leave it as it is now and move on.
Yeah, and I would say as to that, I don't want to see people talking about dividing it by a binomial without tossing out those values that make the binomial zero.
Right.
And then I think it's more complicated, and then I think, yeah, I don't think we need to do that.
And I am absolutely fine with what it is, but I want you guys to also realize when you don't put it in there, then people avoid doing them. They don't talk about those connections. And that's, they just don't do
Okay,
it.
and then, well, so here's what I'm gonna do is I'm gonna put it in there.
No, don't move it in. Move it.
Okay.
Move it.
Okay, and this is where I didn't put in cluster items. I think we're starting, are we still in algebra? I think that's functions. Function. Yeah.
Functions.
You would, I don't know, any less caution, right, to go to the restroom? Is that okay? Or somebody else wants to register? I'm gonna say
And there's the R.
How do I build functions and write expressions that should not be always for common algebra sections?
Did you hear that we want our expense forms back because we figured we'll have dinner? And we're talking tonight. I have not been here, that's what we are, right?
I have a conference call at 4 o'clock I have to do today.
Girls have to do what girls have to do.
Pretty sure I have to leave it in.
What?
I'm pretty sure I have to leave it in.
I do.
All right, have to bust it out for another one.
Yeah. That's probably what I feel like I'm here for the sit. I just wish I was a more valuable member of this.
Oh, good.
Every once in a while I feel like I say something about it.
Yes, no, I was saying at the very, at the very least, and then you do the other stuff as well. So.
No, yeah.
And what happened, we had to write a bunch of kids, but they didn't do so well on their algebra EOC.
Gee, after 5 months of class, well, you're fine.
And there was a little bit of some mayhem in the district because parents didn't know that it was never told them. It just kind of happened. And the reason we did it was to, of course, boost our score for accreditation. But my frustration is they did it again this year. We did it to the kids again. There's people that started the elementary. And it gets kind of sketchy because of the way A+.
Yeah, I'm pretty
We
sure.
had 2 kids out of 25.
And we typically are so bad at
And it messes up their A+ qualification. And these are great kids, I mean, but they got kind of, so that's
incentives to incentivize the wrong behavior.
Well, and I think it's going to be all right. I think the way it's changed is as long as they lose the next time, then they'll be okay. As long as they get proficient on their next EOC, then they're okay.
Oh.
But what happened was my school district, for 8th graders that were taking algebra, they didn't give them the algebra EOC. They gave them the 8th grade EOC to boost our scores for accreditation for 8th grade math on the math test. And then in December, they gave them their algebra EOC. So while they were taking geometry, so 2 out of 25 kids didn't get proficient in that basic. Because they both start counting in 8th grade. It starts counting on the algebra EOC. The high school EOCs or whatever the, right, the way they explained it to their parents was that they couldn't take both at the same time, that they had to wait. But how it was, the parents didn't know that. They didn't know any different. And then the kid comes home and says, oh, I know, right? So I got back to the back. And then they understood that it's only
who have to take this into account. So how much of this can we put into algebra and geometry?
And that's interesting, because when it came back, they said, "Oh, well, that's that." And I don't know.
It's hard.
I don't know, but that was an area, you're not making a breakers. I think you're on one hand, or on the other hand.
Just talking about. But I thought I might be able to get on this, and I tried to pull out do like cross-reference, but I thought it was going to be a good master story. Yeah, they're HBL and like this frame, like that's the third average of the engineers. So ideally, I would hope we could try to.
When they come back, they will do geometry or something out. And then they take geometry as a temporary.
And hopefully they'll make here.
So this is what I tried to do for algebra 13 through 15 and 16 through 19. And then using the standards and then the score range that they fall in. So yeah, most of them are repeaters, but there's only a few that extend even for algebra 2, if I did it right. I mean, granted, I'm not.
So we have a problem with that.
Yeah, so all you board members who can't change on that, or kids who do not. Most of my kids will either go straight to our state or they'll go get it.
Like a applied math or something.
Right, it's all done like the calculations and
We'll start back up in about a minute so that we can kind of get going here. 15 minutes.
In fact, they had a tech math lady who started an ag math, and so most of mine will go on this competitive.
This is what we were talking about.
Yeah.
The ACT ranges and where some of.
Those things fall.
Yeah, and if we have them covered.
Yeah, make sure that they're there. The other thing that we need to, you guys to think about is we're gonna have to somebody that puts all of the 6 through 12, like we've got it now as separate things, but it needs to be one document. Is it, do you feel comfortable with taking the Word document, the separate Word documents we have, and then putting it into one document?
I can do any of that kind of stuff, you know, like the formatting stuff. I can do any of that.
I'll have to resend mine to a PDF, I can see.
So, because we just should be one person that win the final points, and it's 6th, 7th, and 8th grade, if it's pretty much a form, you could already get started. And then when algebra 1's done, send it, geometry's done, but you wouldn't put it in until, because it's gonna have to be reformatted with page numbers. I mean, we put the page numbers in yesterday, did that. We want to print it out individually, but as a team, we can do that. Because if we have one document that, because I don't want to send out 6 links for the surveys and 6 links for links to the document. And so if you would take and put it together as a Word document, put all those components together, that would be great. And what we need though is we'll have to figure out a timeline of when we need to have it done and ready, so that you can say, this is when I have to have it.
A Word document. We're going to upload a Word document?
No, but we need to send it to you in Word.
Yes.
So that you can put it to a PDF.
Yeah.
Yes. Yeah, let's see.
And then you'll do,
Yeah.
you
Say you want to send out 6 leads.
Well, there's going to be a link there. There's going to be a different link for every, isn't there, for geometry, for all of those. So that would be 6 links. So I don't want them to have to click on 6th grade after 6th grade and click on the 6th grade link if they're going to do the 6th grade, 7th grade, 8th grade, one survey. I'd rather than have it as one document for the math, 6 through 12. That's what we had talked about originally, is one document for 6 through 12.
Yes.
Okay, and combine that together.
But the
one-
surveys.
Yes, yes.
Okay, that's.
So that's 7 links total rather than 5.
I think
Gotcha.
they're more likely to the other, like, I'm looking specifically at seventh grade stuff, if it's in one document, I can just forward one, or if that is missing isn't covered in A, isn't covered in stuff, I'll scroll as opposed to going and opening another link and
Right.
trying to do it.
And they can download the whole thing and keep it, and, you know, and what we'll do is we'll just provide them a link, because you can give just a link to a Dropbox link, but it doesn't have to, you know, that we can just put that in and link to the Dropbox folder where they can't edit or change. How comfortable do you feel with putting that one ready to get it for Google Docs when you get it? So if you could take the responsibility of getting that together, and then so we'll do the timeline, and then she'll put the whole document together, then it works, you're in good shape. And Rose is going to help with algebra 1 periods and some of the rest and things like that. Cool.
On the one we got here right now, third word down on the left side, form should be from.
Yeah, I saw that. That was good. Okay. I'm going to start numbering these and come back. I don't have the cluster names there at this point, but we haven't decided on this. And this was also addressed in 8th grade, but it was an introduction in 8th grade, and this is an issue that they have trouble with about in exactly one. So some of this was also introduced, but the difference here is now we're using formal notation that you would not use in 8th grade. Okay. Okay, so looking at number 1.
Hello.
Really, really important.
It is.
Where are you? Sorry.
Understand that a function from one set and that one domain to another set of output one range, also each element of the domain is one of those. I'm not sure how to fix it, but I don't even know really how to bring it up. It just seems really
Well,
extra wordy.
I don't know if we need to leave the input in there called the, understand that function from one set, the domain, to another set, the range assigns to each element in the domain exactly one element of the range. That's kind of a common definition of functions. It's pretty specific to a definition of functions. Do we need to leave in input and output in algebra 1? I mean, that's the terminology that's used, I think, in 8th grade. But do we need to keep it there, or do we just take it out? Take out input and output. We could also consider, understand that a function assigns from the domain, from one set of the domain to another set of the range, or assigns exactly one element of the range.
Or you could also get rid of the called and called the, and just have the name in parentheses.
Yeah. Yeah.
That helps.
Yeah, because I think what they were trying to do is bridge, and I think the reason it was probably there is for those kiddos that maybe didn't take 8th grade math, but went straight from 7th grade math into algebra 1 and had that terminology there. But if I'm teaching that in 8th grade and I have 8th grade standards, then I would assume that I would know all the definitions for those kiddos.
And what was your reason for taking out the word input?
Well, it's language that's used in 8th grade, it's not used in high school. So, any other suggestions on 1?
Well, I guess I don't care.
Speaking out of her, please.
I never had. But I noticed that we're back to output.
I'm just going to mention that, instead of under A there, you've got input or output, instead of domain and range.
Wording.
Good catch. No, it's the range. Yeah, it is. Range function. Then notice the range doesn't
So we're talking there about the whole range as a whole.
domain X. I mean, I fight with that all day. It is not to tell me that a domain is two. You know, they have to understand that the domain isn't that. It doesn't always have to be, but it almost always is.
Yeah, well, I will take care of that. See, when I read that, I was about the individual values of X, for example, for f of X equals 3x plus 9 determine f of 0, 3x plus 5 determine f of 0, so we're looking individual X values. But I can be happy either way, it's supposed to be clear to me. What's the pleasure of the group? Are we okay with this, or we want to make changes? Okay with it, so we move on to 2? That what corresponds?
Well, you would say domain value.
Our element of domain, yes.
Domain element or domain value.
That's to the what, say?
Domain element or domain value.
Which would you prefer?
I think element's fine.
I agree.
Elements. Range elements. It's not just one element.
Yeah, I think of it as f of x, the set of values for f of x make up the range. The set of values for x make up the domain. So, I mean, I'm not trying to get wordy, but I guess what I would do is,
F of X denotes the elements of the range of the function, and F that correspond
To the elements of the domain.
needing a space after f of x.
Yeah, well, and we'll take care of that. And I just mainly concerned about getting to the notation yet, and so those things we're gonna go back and do, but we're gonna move on to that, let's move on. So, 2, are we okay then with 1? What about 2?
I just usually say functional notation.
Functional notation?
Adverbs, I'm sorry, adjectives, no.
Comes from the function of the.
Yeah, functional notation is not one that I normally use.
Yeah. You're right, it should be functional notation.
It hurts you. Is the first use function notation different than where it comes later? Interpret statements that use function notation?
You mean use function notation to evaluate functions for their inputs?
I don't think I would use function notation to evaluate.
Right.
It just seems like we have use function notation twice, and you know they are different.
We could change that to evaluate functions for inputs in their domains and interpret statements that use function notation in terms of the context.
Is what you really mean though, using function notation, evaluate functions, in other words, you're not just saying plug in 3, you're saying find f of 3.
Yeah, I think that's what it's saying.
Using function notation by changing it to using, would that clarify anything to it?
I think so. Well, I think that's what you mean.
I think, yeah.
No, that
Here we go. That's when we cut and pasted the things together and this as well. Okay. Are we okay with 2 then? Let's look at 3. This is, I know, a discussion that Roseanne brought up about putting sequences in Algebra 1, but I don't think we had a consensus around. So it's there for now.
Well, okay, so we're talking about 3.
Yes.
Recognize that sequences are functions, but that presupposes they know what sequences are. So, was that your question?
Well, I think
Possible that we're not going to do it in Algebra 1? And if so, you remove that, is that what you mean?
The question was raised, about doing sequences in Algebra 1, period. And so, because there wasn't a consensus in the group, or nobody really else had input either way, we left it there. And sequences are still in the Algebra 1 curriculum, so we just need to decide as a team where they really belong.
Do we want to discuss that now? Then, is
We
it
will have that discussion about sequences, period, in Algebra 1. Obviously not series, but sequences, linear and arithmetic and geometries. If we're studying exponentials, we do, arithmetic goes with linear and geometry goes with exponentials, as long as we keep them fairly simple.
Didn't I see that somewhere else?
It's down, we have
It's
right
further down.
It's
Further down.
usually.
But I think the
This
discussion
refers to, Kathy, does that refer to like Fibonacci?
it could, this could, yes. The way it's written, this one could.
Certainly keep it out.
The way this one is written, yes. The others are specific towards linear and point arithmetic and geometry. So,
It seems like it makes sense to me, it talks about linear and exponentials and
leave them there.
connect those to the.
So, and I think that's what we want people to do. Don't teach us something separate necessarily. It's teaching us that this is a way of representing. This is a linear growth. This is an exponential.
And this is really the place where they would learn what a sequence is.
Right.
To be able to recognize it as a function, you would have to talk about what a sequence is.
Right.
And it makes sense.
Okay.
Again, it's a matter of how much is in each course kind of thing. But it makes sense to do it here.
And I think that might very well get us some feedback from the survey. The survey may say, a lot of things, this is too much for Algebra 1. This is something that we can move to another continent. So, I think sequences
You're
are
spending
still,
so much time talking about about, that a linear function and has a constant,
right,
addition of a constant,
right.
that an exponential multiplication by a constant ratio, that just seems to.
The
make
natural
sense to
flow.
do that.
How would you said to recognize the form of sequences and relationship to functions?
Tell me what you mean by form of sequence.
Okay, and well, that's what I mean. It's something that you could have examples after that, well, about the different ones that you want them to cover in Algebra 1.
Well, on them, we tell them to write.
Yeah. And look, I mean, I think this is just where they discover what sequences are.
That's why I
Hold on, I'm almost finishing it. And even if you aren't talking about Fibonacci, which is not that, it's just so that they can see that that's a recursive
Right.
form. That there are different forms of sequences, and that you're talking about building those. I think it's fine.
I don't have a problem.
All right. So,
Especially since it talks about further down.
further down. So,
Yeah, I would take that much further down and leave it up here and make it like part A, B, C, and D, because they all feel sequences.
Well, I think this is recognizing the other functions and on down, it's.
And you remember what we don't have in here is we don't have the cluster headings in there, because it's our ran out of time, we got through all the different functions. I think if we insert some cluster headings, that might make more sense than what we're dealing with. Okay, so are we okay with 3?
Yep.
Let's go to 4. And the third line there shows you showing
I would, like for this kind of group to make sure that once again, when you put that heading in, I think there should be a heading above or to define that it's linear exponential logarithmic again, so that we're not.
Mine wasn't your limit.
Right.
It also could be scary.
Right.
Yeah, that was really, maybe just make a note next to the floor, LAQ. LAQ in heading.
And a couple of those in this section.
And is there some awful lot issue or kind of like this small just can it be split into, something in the A and the B or something? I mean, I don't know.
Sure.
I'm not take time right now.
Just do it, yeah, between
Can't it be?
linear, it's going to be just one
Split into A, B, C.
Well, can it be divided? I mean, there's a lot in that paragraph.
Yes.
Paragraph, instead of standard, right?
I agree.
So if it could be split up kind of like that.
Yeah.
Splits.
Could be
So keep that in mind, Andrew, how we want to split into,
That should be plural. That should be plural.
and this,
Plural, that should be plural too. Yeah, and this right here.
and then, so those are things that I can't see, and
Okay.
the rest of those guys will talk about those things. Okay. All right, related domain of a function to its graph. So we're okay with 4 the way it is, we can split this apart into like hidden behaviors. Okay. Questions, comments? 5.
Is there a reason you limit to domain? Couldn't it be domain and range, or maybe range is somewhere else, but, I mean, I think that's possible.
So keeping with the range, because that does kind of tie back in with the one above, we're talking about hidden behavior that's going towards positive, negative. So would you like to relate the domain and range of a function?
I mean, I think those things go together.
Yeah.
You could do
Yeah, I
that
had no problem with
together,
that.
so.
Yeah, I have a problem with that.
Well, I wonder if it's because of the button, they did talk about maximum minimum.
Right.
Yeah,
They talk about maximum minimum in behaviors.
Maybe they thought it would have done,
But here's where you're actually saying, talk about the domain and range, exhibit the graph, so.
but makes sense.
Okay, yeah, that's about 6.
You need that forensic or, that, what's his name?
That's true. It's in the cluster ability, we'll talk about it. I'll put that in red.
I need to talk about that soon.
Cluster element.
So the aggregate change, you could split that across the A, B,
And it's just kind of.
So if we split it into A, B, we have to have a header.
Right, so we'll say average rate.
Okay, split into 2, I'll just put a right question mark and split it into 2.
With a question mark.
Yeah. Okay.
Yeah, it doesn't say that, it doesn't say one way or another
Okay.
how you're meant to calculate it.
Well, are you talking about determining the average rate of change?
Yeah. Yeah, the question was, do we approximate it from the graph, or?
Don't you think they could do it either way? For a graph, if I had a graph, I would have to be able to approximate locations of where the process, coordinates, right? I have to approximate coordinates to be able to do it. So
So what's the other way?
well, if I had an equation, if I had, the table.
I think what we're saying is, does the approximate word go with graph? Approximate.
Okay, given a function in graphical or specified.
You're saying you can't determine it from the graph.
You can because it's points, but
Yeah. Okay,
But you could also approximate it just from the picture.
And I'm fine, it's just that we were very clear before that the graphs were approximations.
Depends on the graph.
Well, okay,
Yes.
you can do what it's not.
And I think that there's a number of times I know, like I just wanted to approximate the rate of change. They didn't have to give me an exact value. I'm looking at the graph and approximately. You know, and part of that is I can see if I have two graphs together, looking at the rate of change on this one, average rate of change is more than it is here. So it's just kind of like an estimation that I can use. So,
The question of more determined.
I
Yeah.
think so, yeah.
But the graphical is more approximate.
Yeah, you could make a parenthetical that just says, you know, estimating in graphical cases, if you want.
So, would you want to put that in parentheses here?
That's where I would put it, yeah. I was just trying to make it simple, but
Estimate graphically?
estimating
Graphical
in
cases.
graphical cases.
Yeah, I think, yeah, for graphical, in graphical cases.
That way you can just have it looking at a slope rather than actually calculating.
Sure. Okay. And we also, of course, we're about possibly splitting this into two parts, which the Algebra 1 team will have to have a discussion shortly after that, to split this up. Or maybe this is. Seven, any questions on seven?
You want to itemize what key features you're having to look for, maximum, minimums, and those type of things?
I think we did that, but.
Yeah, I know you mentioned up above, but I was just wondering if you wanted to reinforce it here.
I mean, I think once I've seen key features, I know what key features they're looking for, but do we want to put them back in again? It's up to the group. I can put them, I'm fine with not having them in there, I'm fine with putting them in there. You like that, you not as worried when you say there, but
You
you
got
got
it
it.
once.
So key features, if you feel that key features are already
As
defined.
long as this is going to be fairly close to that one, fine.
Well, it is, I think, it's like just within a couple after that, so it's like 2 or 3 after that.
On that one, in Missouri learning standards, they do have absolute value in defining piecewise and step.
That was, and I agree with that we didn't have piecewise, we didn't have step, and we didn't have absolute value, and that was a part of the discussion. Some people wanted it out, some people didn't, so what's the feeling?
I don't have, I was going to finish my sentence by saying,
Sorry.
so is that something that we are going to make sure that we tend to and algebra two? Take it out.
We have all those functions in there, yeah.
So we're taking step functions and piecewise functions out of
You know,
algebra.
when I expect algebra one to have absolute value, to be honest with you, but
I would think some absolute value, some simple absolute value functions. So, and are you talking about 7? And are you talking about question number 7?
Yes.
So shall I put in, I'll just put it in and it'll be a topic for discussion for algebra 1. Is that all right?
please,
Topic for discussion. And Rosa brought this up, originally the statement was at part A, B, and C because some of the things were algebra 1 and I think some of the things were not. We shouldn't have an A if we don't have a B.
I would like what you have in parentheses to somehow be embedded in the standard instead of on the end of parentheses.
I think it's almost the same.
So what I'm going to say is maybe type in this, will this be in the header, because we don't have a header for this section.
Okay.
Okay, so if I put that in, oops.
Or put it together.
Yeah, I'm going to put it in red so let them know that that's what we're looking at. once we put the letters in. If that's not, and if it is, you're right, we should probably incorporate that. And do we all agree that we should have an A plus we have a B?
So when it starts as translate, should be the A, is that what we're saying? Then
Well, we have to have a title for that, but I wouldn't just do an A and B without some kind of
Right.
description before.
But it could be something like translate between forms and use the process or whatever we're going to say there, but somehow is a description overall of A and B.
Right, so we would need to come up with a description for A and B. Okay, and so, and I'm going to say,
Because if we're putting in that it's linear, quadratic, and exponential, A seems to only do quadratic, so it shouldn't be address something about exponential, about looking at the exponent, so.
and it could be something we can do later.
Yeah, I mean, maybe just type that in and we need to add something about one, those other two, if we're saying it's inclusion.
That would give you an ABC.
Only
A's. Okay, so are we okay with that, to go back and make those modifications and changes? Okay,
same thing with mine.
header. So it's in the header. What if I just put this? Now here's what we're talking about, we'll get into arithmetic and geometry.
So is this a new header?
I would assume,
I'm sorry, what?
starting with 10,
Is that a new header?
because now we're dealing with sequences. But there's only one sequence. There's only one thing about sequences.
So you scroll back up just a little more.
Mhm.
Okay, thank you. So does that go somewhere else?
Arithmetic and geometry sequences.
Yes, does it go somewhere else with the other number 4?
Josh, so it should go up there.
And research should actually go here before that, because
No.
that's where you're defining what the sequence is.
The ones we just talked about are about interpreting things. And this is about buying them, or building them, or creating them, or, so it's a
So what's
different
the
process
interpretation?
they're talking about.
And it's- so this is kind of a lonely angel right now.
What did you combine with that other company? So it was back in 3.
In 3, go through,
Or they can both be moved, or,
say, plus 1. Something
As a
like
sequence header.
Define and analyze a sequence of
Yeah, a sequence header.
that kind of
Okay, so, but when we look at this, so we're going to try to group those together. If we decide that one team can decide to take that into consideration. Right, arithmetic and geometry considers, Chris, please.
And do you want to think about or talk about the specific notation? And I guess what I'm asking, you know, I know for 2 we never do this, but sometimes in the lower grades they use the next now notation, which I don't think is bad, but at all. But if kids are expected to use the subscripts, you know, then maybe we need to say that.
Well, and that's one of the issues that they have a lot of difficulty with is the subscripts. They really seem to have trouble.
It would be nice if we defined a recursive quotations for the assessments made,
Well,
quotations.
that's
There's
what I'm
different, you're
thinking.
right, there's different
And
quotations.
part of the, and it will make a difference, and part of the issue that will be different textbooks use different notation, which makes it difficult to do. So, do we should we as a group, because that will come into algebra 2 as well, to really reflect and think. But I don't think we have to put it here specifically now, but that is something that in the final draft will have to be there. If we would decide on the notation, what we want to use. Right now, isn't there a formula page rather than one that doesn't use it? Is that
Yeah.
a notation? Because that's what they're accustomed to, that we want to.
Well, I don't know, I mean, it's been different over the years. The one they have right now is for algebra 1 and algebra 2, and, I always make fun of it because I always tell kids, you know, if you need this formula sheet, write it to me, and it's not gonna help you, seriously, you know, and so, but I get it out for them and we look at it and there's very little on it that really I think is of any use, but I do look at those. And I noticed, they use A's for arithmetic and they use G's for geometric sequences, so you have G's at in. And that's not necessarily the way books that I've seen have done it. Although I don't think it's a bad way. So, but yeah, they are going to do something on that sheet. And maybe if you're a kid and you're trying to do your best on a test, maybe you do go back and just check that, you know, that formula, just, you know, am I doing this right?
So the subscript is the number of term.
The subscript is the term, yes. Those are the counting numbers. Or G's of 1, yep.
Because sometimes they start with 0, that's what I'm saying.
No,
It's different notation.
Right, and they do start with 1, so.
Which actually is something that if you do it that way, you have to really think about when you go from function to notation, to that notation, because in a function, the y-intercept, we think of as kind of the beginning point, but not really, but I mean, that's one of our key points, and it doesn't even exist in the, you know.
So I put on there, Julie, notation, just as a question mark, and I don't think we have to put it here, but if we decide as a team that that's an important thing, that we should come up with what we think the notation should be, that could be our final draft or recommendation that we'll submit. Because I don't think that that's something, because we're going to have feedback on it from everybody, and I'm not sure when we get tied up on that.
Well,
I mean, I think
yeah.
we'll be consistent, but.
And I guess what I'm saying is, I don't necessarily have a preference on notation, but I think we ought to say what it's going to be.
That's fine.
Otherwise, we're setting kids up to follow their different textbooks and you know.
And the textbook is not going to relate to what the state has, and if the state test or who that, you know, whoever the test is.
Right, not necessarily. And after the first year, teachers will know, but.
And maybe that could be something everybody can think about, and then, you know, if you have ideas and suggestions of what you think it should be, make those recommendations, and then we can come together as a team. But I don't think that's something we have to decide today. But I agree with that. So, are we okay just by putting the notation and moving on?
I'd like to just say one caution about the possibility when we discussed moving the sequence up to the other sequence. The caution is that we're connecting them to linear and exponential, which in between those two standards, we talk about constant average rate of change and things like that. So move it up there to avoid that.
Well, we're talking about having a separate header for these under sequence, so that it's the different parts of the sequence that you're looking at all by itself, not with respect to the other things around it.
Well, but I mean, this standard has in it connecting arithmetic sequences to linear functions and geometric sequences to exponential functions.
Right.
So if you're going to make that connection by looking at modeling situations, you're going to be talking about constant addition, constant multiplication, which happens in those other places. So I'm not saying you can't do it, I'm just saying
Think
be
back.
careful that.
Be careful what we do. And
The part for the worse.
right, and we can put it together, and if it doesn't work, we're going to, but it's a draft, we can always go back and change.
We could always move the up and down here too. We could move 3 down and 4 changes.
If it fits there.
That would not have that issue.
Okay. Next one is about transformations. Pardon?
Is and the right word?
Wait.
When you're distinguishing?
So you still?
Oh, you got the low.
On 12, okay. Any questions on, well, we moved to 10. So any questions on 11?
Just punctuation.
Yeah, and Rosa's going to be the punctuation queen. Right? She got it, okay. Okay, now, you're on.
I was saying, your verb is distinguished, I'm not sure that and is the right.
Well, you're distinguishing between the situations that you model with and your exponential functions. You're not necessarily distinguishing, I guess, it might be, but I don't know.
And I think that in parentheses in A was taken from either Georgia or South Carolina as a possibility, but I don't know if we want to include that.
Yeah, the first two sentences under A are, something needs to go.
Well, this can be shown, it has to be shown, not be shown.
Say what again?
Well, this is what you want the students to do.
Yeah, it can be grown by equal factors. Can be grown.
Oh, it can't be wrong.
Can be grown. Yeah, it can.
Can't be wrong.
No, it can't be grown. That's what can be grown.
The first part, then you can't be it, then it can't be the boy out of it.
Yeah.
But isn't it really change? I mean, I don't know, are we talking about this having to grow?
Yeah.
And also, when they're doing this, I mean, I love the activity or the whatever approach, but what they're doing is really, at least initially, is doing it from a table. I guess you say that down here, though. I say that down.
But they say it's
It's changed by equal differences over equal intervals, because it could be sloped like this, it could be sloped like this.
Right. So, yeah, no, but
Erosion change.
So how would you like to push your wording?
Show that the linear functions change by equal differences.
Yeah, but I'll get across that, and put changes, and put change there, and see how, and let you read it and see.
And you don't need can be, we'll just change on exponential functions too.
Right, and so, but that sentence, just that one sentence, is that okay? Because then we were just.
Yeah, we only need one exponential.
So that the new functions growing, change by multiple differences over equal intervals. Are we okay if you want to change growing to change? Okay.
Yes.
And so that exponential functions, oh yeah, function done. Change.
And I thought you were putting it in exponential.
because that's the exponential function.
Growth.
It's exponential function is what we're changing. So we want change there?
Yes.
Is it okay? Okay.
And this can be shown by,
Yeah.
versus this can be shown.
Yeah, that would be right. So that shows, that give the teachers a way that they can go about teaching that, so it gives them ideas. Because I think that's something that teachers don't traditionally do, they should be doing, but this gives them ideas of ways that they can do it. Say that again, please.
They got this can be,
So you're saying,
so,
should we say IE part?
What was your question?
Well, David was talking about taking out this can be shown, and to say, making a list, or do we want to say, show by algebraic proof with the table showing the principal differences, or by calculating?
this was
I think an EG would be,
What?
with an EG.
An EG? Okay. Yeah, we always do. So is that right?
Yeah, rather than accommodate the differences in here.
Well, those are our words, we both write that down. Take care of that.
So then what's the difference for B and C? Is that like a real world situation? Is that what?
Yeah.
Okay.
Recognize the situation.
Recognize the situation which we have. So the first one would be, I just give them an equation. And the second would be, here's real life. Here's situations when this
Be
can be.
situations.
Right, different situations. Situations.
Yeah.
Yes. You didn't probably add anything down. Okay, thank you. Thanks for catching that.
And to match B, if we say changes in B, we want to say changes in C rather than growth in case.
Or say that again.
Yes.
Yes. Say it.
Well, it is gross or
On
decay.
C,
It
say
says
that.
changes
that's
rather
okay.
than growth in case.
Okay, I can only hear one person at a time, listen.
Just instead of grows or decays in C, we just need to say changes, like we did in B.
I kind of like the growth or decays though, because that's the language of exponential. I think it's nice here. I think we changed it before because we didn't want to say it's just growing, but here we're saying both.
Right.
I kind of like having at least once in here, because that's what we talk about in exponential growth.
So back with A, do we want to say grows or decays by equal factors, or just
No.
say changes?
Could, but I think maybe once is enough.
The emphasis on situations, but it goes with it.
One thing when you talk about decay, you think of those exponential shit.
Right.
Gives kids those verbal cues to.
And here's again another arithmetic and the sequences. So it comes up again. So we're going to have to decide when we talk about sequences, there, because it is, sometimes we're interpreting, sometimes we might be creating, sometimes we might be something different. So the difference in the headers is going to make a difference as to where they're placed, whether we can place them together as one. And so that's down to 14, we'll have to ask and talk about that. But on 13. And I'm not sure, I guess the linear and exponential, but I don't think we need linear and exponential in here. That's personally me, since we set everything in exponential, and we set arithmetic and geometric.
Yeah.
I don't think that belongs there. And I think we put it there originally because we were discussing it to limit it there, but we didn't ever go back and take it out.
We've got graphs and tables on 14.
Same thing on tables.
Tables.
Those are going to be tables? Come on, tables.
I
It's a
know,
pretty good
I
tables. Okay? 14 times 15. Okay, 2 thumbs up. Are we ready to go for statistics? Yay! Woo! This is the last shot.
Give me hope that there's lunch in it.
Yeah, I'm just kidding. So do we want to do statistics or go to lunch?
Can we do it now?
Yeah, it's done and then lunch.
Okay, so there is one that we'll have to talk about, I think, at the bottom, but,
Thanks, Kathy.
it is just a little tweaking. It's something we talked about before. Any questions on, one? Two?
When we went over the standard, separated it out, previous meeting is to, on the statistic, what was going to be in which course. I had noted that we had said standard deviation was going to be in algebra two. And we, when we were working
Okay, is
out
that
algebra
on-
two last time, we weren't sure.
Okay.
So I saw standard deviation here, and I wasn't sure whether that was in algebra one.
Algebra has
deviation and algebra 2? Because I haven't seen the statistics from algebra 2, so I don't know.
Put it in, we put it out last night, but I was back in my notes, but I was over either way, I just want to be sure.
So, do we want to take standard deviation out or leave it? Nancy, that doesn't mean you absolutely got a deviation, having that in middle school.
Yeah, not sixth grade.
Which is sixth grade, so are we okay with standard deviation in eighth grade? Algebra 1?
Yes.
But what are you going to do with it? I mean, I guess.
Well, I think it's you, what this is using and comparing, and I don't think they have to compute it, do they? I mean, this doesn't tell me the kids are going to have to make computation. They're going to know what standard deviation is, use it to make comparisons, but it doesn't look like they're going to have to.
I think it's comparing
Right.
distributions that might have the same mean, but different standard deviations, that might have the same mean, but different spreads. It's really kind of an understanding of what standard deviation is about.
Yeah, this is, what is standard deviation?
And then number 3 has to do with interpreting the differences.
So I want to calculate it? Absolutely no.
Okay, so then let's make that clear, because clearly median, mean, and your quartile range, we would expect them to
Absolutely.
find on their own. So if a standard deviation, I mean.
Why do we not want to calculate?
That's my question.
That's
Why?
my question too.
Okay.
I mean,
That's my question too.
It's a matter of subtraction, and squaring, and adding, and dividing. I mean, it's all, it's not, now, I'm not saying you would do it with 100 data.
Yes, I can think, you could do it, but you want to make sure you're doing it with a really small data set.
Yes.
5
Yes.
points.
Yes.
With a nice mean.
With a limit, should we say with a limited data set?
Yeah, I don't think you have any idea what it is if you don't calculate it.
Well,
And this don't really work if you don't have enough data.
No,
But you can look at very small graphs of very discrete, small sets of data that have different standard deviations that are very easy to calculate. I can show you lots of them, because that's what I use all the time to start with.
So Bob, how would you word that? So that we know that we don't want to use a huge data set, that we want to limit it to a
So
small.
put in red, small data set, C bomb. Well, right, comes into you.
And they get it, yeah.
and I do think, yeah, that, I
I'll
agree.
email in there.
But I do think for some kids, and I'm such a one, to get something, I have to go through it myself. And so, if I take a, 5-point data set and calculate the standard deviation, that's how I learn what that really is. Now that particular measure of that data set may not be very meaningful or helpful, but I've learned how to do standard deviation, so that's.
I would just put after standard deviation calculated from small data set or something, simple data set.
C bomb, in a quartile range, so C bomb.
Okay.
So just if you put that word together for me, Bob,
Okay.
we'll take care of that. Okay, 3, interpret differences in shapes, center, and spreads in the context of data sets, accounting for possible effects of extreme data points.
Yeah, that's kind of what we're talking
Okay.
about.
Seems like some of this has already been done. I mean, I'm not opposed to redoing it or taking it further.
In 6th grade.
Right.
And
And the new and number 2 is the standard deviation.
And I think, again, some of the things, there's overlap between especially 8th grade and algebra 1, because there's some of those kids that will be taking 8th grade mathematics, and will be taking algebra 1, so there might be some areas of
Well, we
overlap.
had talked about too, doing some sort of suggested, like exam, where if you have accelerated 7th grade, you do
Right.
7th grade standards, and use 8th grade, and sugar algebra 1, and use 8th grade algebra. So,
Well, I think it is important to recognize that difference too, in our district where we put all kids in Algebra 1 in the middle school policy, which I totally support, but that you have to recognize that when you compare it to the kids we do have in high school, 8th graders do an enormous amount of state testing, and that takes a lot, especially this year, way worse than ever. That takes time away from the Algebra 1 teachers. So there are going to be things that it's going to be hard to get either way.
I think the more of the interpreter. I think there's much more, if you keep going with this, there's much more in terms of looking at the comparison and doing interpretation.
So are we okay with 3 and 4? Three's okay?
This seems to be more of a sub-theory.
4?
For, yes.
Well, there's set theory and probability, but I mean, it's talking about looking at
Yeah.
comparing two variables and how they, you know, you get into the idea of independence. Independence is here.
Well, they'll give us independence.
No, it happens in middle, it happens in geometry, that's independence. But the two-way frequency table is a really good way to talk about joint and marginal condition probabilities.
I like the two-way frequency.
Good explanation.
There's no sense of
Really satisfying, nice.
So, and 10.5, we're not, I'm sorry, but 4, we're okay with 4?
Do you use all the frequencies or do you go with the probabilities?
Same
Kind of
thing.
started with-
Same thing.
Okay, so 5, and Amy said this, well, and we have the same issue here, we have an A, because I think this was one where the heading was this, and A was going to be in algebra 1, we talked about B being in algebra 2, so that's why that's there, so.
I think some of the, I think it can be divided into an A and a B or an A, B or a C. I think there's a lot above the A.
So your suggestion is to, and then I mean, you said a sentence doesn't make sense.
Well, when, look, you have the word context and then determine, it's like determine is a new sentence.
Right.
Yeah,
I
that
think
is
it-
what you said.
Okay.
And I think that, I mean, maybe that's maybe where you can start with an A
Okay.
or
Yeah.
something.
So-
Yeah, good catch.
Yeah, that's a good catch. So, and I'm going to, so I'm going to highlight, was it this for context determine? So I'm going to highlight that. Because that does need to be looked on. Any other suggestions for Tom?
Is period supposed to be after related and cut?
That's a little on that.
Oh, okay, that's where you did it, after related? No, you've got it in a different place. How the variables are related, and then period, given graph or chart of data,
And
or
that-
context determined.
And that, yeah, are related given graph or chart data. Or context determine what type of function is most appropriate to multiply.
So you don't want a period after the related and the capital and given graph or chart of data. Or
And a comma after determine. Or context comma determine.
So what do we want to do? Do we want the algebra 1 team to work on that, divide it into several segments?
Actually, it's semicolons in here. Semicolons.
Yeah, probably, it was probably a typo as we type in, so we'll work on that. So the algebra 1 team, we're going to look at dividing that into multiple parts and the punctuations involved there.
Tiffany, you said that A was already in 8th grade. I read a note on that somewhere.
Yeah, you had, Tiffany had said that, and I think I just took it out.
Do we want to keep it though, or and is the reinforcement good, or do we not need it in the algebra 1 level?
Well, up above it says to determine what type of function is most appropriate, so it may not be linear.
So then an A is that is.
Right.
So we just keep living around that, is that what you're suggesting?
Using bivariate.
Well, yeah, I mean,
Fit a function.
yeah, it didn't say, in here, it doesn't say linear, it says fit a function to the data. Use the functions fitted to solve the problem in the context of the data.
Eighth grade is specific.
And B is informally assess the fit of a function by plotting and analyzing residuals, and C is fit a linear function for a scatter plot. It's just a linear association.
So
So,
put that back in
I
where it
mean,
was.
you know,
Does it make sense to put it back where it was before we made the changes in this?
I just think that we should redo this little thing to include those things, because one of them is just, as Bob said, fitting a function to the data or taking a look at it and looking at it. And the second one is about the residuals, whether you want that in there or not. The third one is, if it is linear, then we fit something to it. So there's a little bit more involved when we're in 8th grade.
So Algebra 1 team work on this one, and then they send it out to the group and let them know.
Well, and I would hope somewhere that that's done with technology, or could be done with technology, or we make some mention.
Which is the one issue that we'll talk about a little bit down 8 for just a few minutes to decide, because that was a big, so we came making changes, and I'll put in here, Margaret, what you just said, technology, and question mark, that we come back and we talk about that, go to Algebra 1 team, or do you have something specific you want to say?
I just think somewhere in the document, the use of technology for statistical purposes needs to be mentioned.
Well, you're not going to be fitting other curves on linear. In fact, you're really not even going to be fitting linear
Without.
technology.
That's right.
Unless you're just sticking spaghetti in something.
Which is
Exactly.
which is what is done in 8th grade.
That's the middle.
That's the difference here, is that you do use technology.
So I think that needs to be.
Okay.
And if
So-
you're going to use technology and you want to have any clue what technology is doing, you have to talk a little bit about residuals. That's why that's in there to begin with, is because the residuals are being minimized, and that's what the technology is doing.
That's what it should be done,
So
absolutely.
either you're going to do that or you're not at all, I think.
And so, or put that back in, looking at residuals, and we'll see how it goes, and we
It
put it
doesn't
out.
mean they have to do, you know, like you said, the technology makes it where you can still understand it without having to do every single thing.
Right.
The thing with technology is it doesn't give you the idea of how you minimize the residuals by trying different ones. It just gives you the solution.
But you can talk about that's what it's doing. You're right, it doesn't take out because that's calculus. So it's not going to be, you're not going to do that now for 1 or 2.
So, Algebra 1 team, we're gonna work on this, look back at it, and probably send it off to Bob too, since you're our stats guru for some feedback on. So we'll look at that, we'll let everybody know when it's ready, and then roll it and send it out. 6 questions on that?
Do we need greater change in constant term? The algebra one level?
I think we can take that out. I think you're right, Margaret, I think we can get rid of that. Although, when we talk about the intercept,
Also, why was when you talk about the context of it.
Yeah.
context.
I think it helps interpret, I mean, that's the part of how you interpret.
Right.
You know, you have your fixed costs and your variable costs, all the that together.
So do you want to leave that for now?
I don't know.
Okay.
So that's the y-intercept?
Well, that's what my question was, we're just talking about the y-intercept here, we're not talking about
It's
x.
not always called Y. I mean, it's,
Should we say the y-intercept? Yeah,
you say,
We don't have to, but.
well, and Julie, I kind of agree and defer that, because sometimes there's only one intercept, and there's not two. Distinguish between correlation and causation.
Yeah.
And the very last one, and the only reason using technology was crossed out here, and I would like to keep it in personally, is the last time we had a really big discussion about schools expected to use technology.
well, if we're going to go back and look at fitting curves with technology, we might as well do this. And my suggestion is, I never really understood why this one's after 7.
It
I
doesn't
think it ought
matter.
to be before 7.
We can do that.
Could you put determine the correlation including using technology? Some schools could, some schools couldn't. You could define the data set so that it's not necessary, but you know, some schools are gonna bark if you say technology. They don't have graphic calculators, they don't have all that stuff.
You could.
I mean, if you still like it, you can saying using
Yeah.
technology if available.
Using
And
available
eventually-
technology.
Using
Like
that,
that.
I like that.
Because if the teacher has a spreadsheet.
Using available
I
technology.
mean, you know, it's not that every student has to do it, but
But if the parent should.
But I would suggest that becomes 7 and 7 becomes.
And that's a good priority set. And my other question is, I really want to push for us to put technology in here because the discussion we're having about technology and some schools don't have it was the same discussion that we had 12 years ago, doing the same thing. And unless we start moving forward, we're still going to stay where we were before.
Well, I think by putting the word available in there, I think you.
And to me, using technology, to me, says whatever I'm available, I'm going to use, but I'm fine with using available technology.
I see you
It is now 12, or 10:12. What time? How long is it going to take us? Yesterday, everybody was back in 45 minutes. Can we start back up about 12:30,
Well,
12:45?
there may be a little more competition because we got out real early yesterday.